What's up YouTube, this is Dennis Panuta for tutorials.eu. In this video you are going to learn how to build a first-person shooter from scratch using Unity and C#. So if you don't know the C# basics or the Unity basics, you should definitely check out our videos up here and they will teach you those basics. But if you have some experience in Unity already, then this should be the perfect next stepping stone for you to become a real game developer, because we're building this beautiful little first-person shooter here and you're going to see all of the features that you need to get there. And if you think that this is a cool video and it's nice to build some games and get an entire course for free, a 3.5 hour long course for free, then definitely hit the like button and subscribe button. It really helps us out. And also subscribe to our Unity specific channel where we only upload game development videos, and that channel really needs some love, so hit the subscribe button there as well. And now let's get started building this first person shooter game. So let's go ahead and create a new project, and this time we are going to use the scriptable render pipeline. Therefore, let's select universal render pipeline, this one here, and then give it a name. I'm going to call this one zombie FPS. And now let's create the project. So let's look at what this scriptable render pipelines or high definition pipelines means. Alright, so this chapter we're going to use the scriptable render pipelines. Scriptable render pipelines allow developers to write how Unity renders a frame in C#, instead of using the built-in render pipeline like we've been using in the past chapters, which does not permit modifications. Currently there are two SRPs, so the HDRP, so high definition rendering pipeline, and the URP, which stands for universal rendering pipeline. Let's look at HDRP first. So high definition rendering pipeline is designed for high fidelity graphics, high definition and improved lighting, high definition materials, and for the highly seeked ray tracing feature, but also being low performance and needing DirectX 11 at least. So definitely a PC that is newer. So this is not something you would use on a mobile phone. So URP is designed for high performance, being the standard for VR, mobile, and simply having the broadest range of platforms, and is really easy to use, with the trade-off of losing visual fidelity and limited lighting. So which one is the right for you? Deciding that boils down to the nature of the project. Here are a few questions to help you determine which pipeline is best for you. Do you need your project to be optimized and perform well on a wide range of devices? Then you should use URP. Or are you aiming to release your project for high-end platforms? Then you should use HDRP. And as you saw, we are going to use URP, which stands for Universal Render Pipeline. So when you come into your game, you will directly see that it has a bunch of assets directly inside of them. You see here a bunch of folders, materials, presets, scenes, scripts, and all of the good stuff. So if you go to your scenes folder, you will see that it only has the sample scene, which is this scene that we have in here inside of our game. So let's scroll in a little bit. You see here we have a couple of example assets and they look pretty nice. Graphically, they're pretty good. You see here very detailed graphics, and this is something which is quite fine if you have an okay PC. But if you have a poor PC and you would replicate this and have a bunch of different assets, then it will become a little more difficult to edit it. So I highly recommend to upgrading your PC if you feel like this is too slow for you. But for our project, we're going to use assets that aren't too heavy on your hardware, because I think that not everyone has a super strong PC and powerful PC, which is why I decided to use rather low graphics assets, which don't look as amazing as they could, but it will make sure that it will work on even older PCs out there. Quick pause. The video that you're watching right now is just a fraction of the entire FPS course. In the course, you're not only learning how to build a first-person shooter, but also make it a multiplayer game. So you're going to learn a bunch more things than in this YouTube video. It's a 7.5-hour course, and you can not only get the course, but you can currently also get the book with a 50% discount. Definitely check out the link in the description below to improve upon what you're building in this video and become a real multiplayer game developer. So in your assets, under example assets, you will find that you have a bunch of URP materials here. So these are URP enabled materials, and non-URP materials will not work here. So if you were to take or to create a material here, let's go ahead and create one. I'm going to call this one non-URP, and the shader would be the default, the standard one. You see, you get this magenta color, and if you use it somewhere, it will not work properly. So as you see, even though it's set to white or whatever color I'm setting here, it's not going to work properly. So materials have to be URP enabled, which means here the shader has to be set to universal render pipeline, and there you can select different options. For example, an unlit option, and then suddenly it's fine, and you could change the color here. Okay, so it has to be a universal render pipeline asset. Okay, so then on top of that, let me get rid of this material, by the way. On top of that, if you go to your project settings under edit, you will also find under graphics that the scriptable render pipeline settings are set here. Okay, so here, this file is something that you have under your settings with a bunch of options that you have here. So here are a couple of different settings. So we can look at those. You see universal RP high quality, low quality, medium quality, and so forth. And then if you go to your package manager, you will also see once it's loaded that under your Unity registry, you will find the universal RP here as well. In my case, it's version 11.0.0. The universal render pipeline is a pre-built scriptable render pipeline made by Unity. All right, so that's exactly what we are using for our project. All right, now let's go ahead and get rid of those assets because we won't need the example assets in our project. We are going to instead use our tutorials EU assets. So let's go over to our assets here, and I'm just going to drag in the tutorials.eu assets. You can find them assigned to this lecture, so just download this tutorials EU assets zip file, unzip it, and drag it into your project. There you will find a couple of assets. For example, the characters. We are going to use two characters. One is going to be the first person player, and the other one is going to be the zombie. So let's drag the zombie in. This will be the zombie that we're going to use, and this one will be the first person player here that has a weapon plus 2 arms here. So that's just the prefabs for the character. You will also find a little more here, for example, the environment. So here, if you want to drag in the city, so let me reset its position. So this will be the city that we're going to use for our game. As you see here, we can then walk through the city with our first person character and then shoot zombies once they appear. So you see it's rather low poly what I'm using here, and I'm using that specifically in order to make sure that this is going to work well on your machines. So if you want better graphics, definitely you can anytime download nicer assets from the asset store and import them into your game. All right, so let's set up our game scene in the next video. Welcome back. In this video, we are going to set up our game scene, at least the beginning of it. So let's go ahead and go over to our assets, and then inside of the scenes folder, let's create a new scene. I'm going to call this one game. And now let's go over to the scene. I'm not going to save the sample scene because I didn't make any changes. Well, many changes. I added the city to it and got rid of the default stuff, but actually it's going to be fine because I don't need the sample scene altogether. I could even delete it at this point, so let's get rid of it. And now inside of our game scene, let's go ahead and first of all add something to it, because if we look at it right now, it's pretty empty. and that has to do with us not having added any materials to it. If you look at it in your URP default assets materials, you will find the skybox material, and you can just drag it into your scene and look at it in the game view. You see now you have the skybox, even though you don't really see it in the scene window. But let's look into skyboxes and what they do for us. So a skybox is a 6-sided cube that is drawn behind all graphics in the game. So a big box where you would stand in the middle to simulate the surroundings without actually having to create a sun or clouds manually, taking away a lot of your work for you, and also your computer. Using textures like the one on the right, called a cube map, which is one of the more typical ways to do it. Implemented inside of Unity as a material type, the skybox/cube map, but also having the option of using 6 images, taking the component like so, where you have the front, back, left, right, up and down. Or HDRI, more typically used in 3D software, being basically a 360 degrees image. But there's one more that Unity includes, which we all use by default, and that's the procedural skybox. A special kind of skybox that changes on the rotation of your directional light. In some cases that's the best option, but its customization not being as user-friendly. Since we don't need to modify it, but would like to have the adaptability of the procedural sky, we'll be using this one. And why not? The URP included one, and it just looks nice, and I think it's fine. Let's continue with it. We have imported a lot of assets using the tutorials.eu_assets folder, and in this video we're going to look at those assets. So let's get into it. First of all, you will see that we have this characters folder, and we already opened it a little earlier. So here you will find 3D models, for example, the 2 3D models that we have, the FPS character as well as the zombie character. Then we have a couple of animations in here. We have materials. First of all, the skin of the arms, and then the zombie material, which indicates how the zombie should look like. Then the prefabs, which bring everything together. And of course, the textures that are also important for our zombies. For example, here we have the zombie A in our case, but you see, depending on which texture we're going to use, the zombie is going to look differently. Then we have the weapons folder, in which we have our 3D model, which is this weapon here. It has also a black material, which makes it look a little nicer. And then we have this prefab, which is basically going to be this weapon. So it's pretty small. Let me change its size. Here, let's scale it up and let's go over to the weapon. So there we are. This is going to be our weapon here, which looks pretty good, I believe. And we can use this weapon for our game quite well. So then inside of the assets folder, we will also find the environment. You have a bunch of 3D models here, which are, as you can see, walls, containers, even trucks and so forth. So you can use those in order to build your own map however you want it. So feel free to create your very own map using, for example, the sturdy ground and so forth. There are a bunch of materials that are in part of this environment, so we're going to use those. You see, you can also just use those prefabs instead of the 3D models, and they will be good to go then. You of course need to position everything correctly so that it's going to look fine. And then we of course also need to have textures for our 3D models so that they are going to look nice. So concrete, asphalt, dirt, and so forth are the different assets that we have here. And then we have an entire city, which is a big prefab. So the environment prefab that we prepared here, in case you don't want to set this up by yourself. So I'm going to reset its position, and you will see that this is going to be the city that we're going to use. We saw it a little earlier, but this is basically going to be what we're going to work with. And you can, of course, if you want to, adjust this city. If you just want to make changes to the city where you, for example, move around certain blocks. So for example, this building here, you could move this building around if you wanted to, add more buildings and so forth. So feel free to make the changes that you want to the city. or even build an entire city by yourself, depending on what you prefer. By the way, while we are going to use this city in the end, in the next couple of videos, I'm going to show you a couple of tricks and show you how you can build this city from scratch. Okay, so we're going to use the assets that we have available building the city. So you don't have to be able to do it already. You can of course try it, but I will show you a couple of tricks in the next couple of videos that will really help you with that. And you can of course also just skip those if you're not interested in the city building part and jump directly to the player lecture instead. Now looking at our weapon prefab, let's go over to our weapons folder, prefabs here. You will see that the weapon only has a mesh filter and the mesh renderer as well as a material. So it's free for us to edit it now, to add a script, to modify the weapon so that it does what we want it to do. And in the next video, however, we're going to focus on the city building blocks a little more. So see you there. Welcome back. In this video, I would like to start building the city from scratch. We're not going to build the entire thing in this video, but we're going to get started with some fundamentals that will help you to then build the rest of the city as you like. So let's get rid of the city asset that we have here and let's go into our environment here. In the prefabs, you will find a bunch of prefabs that we can use. And the one that I'm going to start with is going to be this road asphalt. So let me drag it into my game and let me reset its position. Okay, so now it will be at 0, 0 over here. And this is where my road will be. And I think it's fine, looking good. But now let's make sure that we extend this road so that we have a bigger road piece, so to speak. Therefore, let's drag in another road piece like so. And now you will see that this road piece is at an entirely different position. So let's reset that one as well. And now let's move it around. So we can of course try to position it correctly here at this point, but there might be an overlap and it won't look as good. What we can use, however, is going to be V, and then we can move around with our mouse to find the order. So hold your V key and then you can snap. You see, you snap the edge. Let me do it once again. So here, zooming in, I press V. And then I can snap it, for example, to this corner over here or to that corner over there. And now let me duplicate this asphalt piece. And now move this one with that corner over to the other side here at the top, for example. And now if I'm looking from a different angle, it will be probably a little easier. So like so. Now let me use this one once again. Press the Control W in order to duplicate it. Press this V key and make sure that it's snapped directly towards this edge. Let me duplicate it once again. Hold the V key and, well, maybe not this key corner, but this corner right here. And let me snap it over there. So this is how you can snap your prefabs so that they are going to be at the same levels and that they are fitting perfectly together, because otherwise it would be a pain. We would always have to check what kind of positions do they have and so forth. But this way we can just drag prefabs into our project and position them accordingly. All right, now let's add some more pieces to it. So here, let's look at our street. Let's say we want to use this piece here and we want to add it into our game, but at another side. So something like this here. But then, of course, I want to make sure that this corner is going to be perfectly snapped in there. All right, there we are. So that worked out flawlessly. Now, if we want to use that same piece for the other corners, we have to rotate it first. So let's duplicate this piece here, this outer corner. And let's first of all move it over to this edge here. But now I would like to rotate it, because this doesn't look correct, right? So let me go to the rotate tool here. And here you can use Control for precise snapping. Okay, so hold the Control key and, for example, turn it around by 90 degrees. So there we are. Now let's go back to the movement tool, which is this button here, or the W. So, okay, now we have moved it to that corner. So first of all, move to your rotation tool. In my case, it's the E button. This allows me to rotate, hold the control key, and then rotate while holding. Okay, so let me go back to the movement tool. Let's duplicate this piece. Let's move it over here. And now let's use the V key to make sure that we position the item correctly. And it doesn't seem like it's correct now. Okay, this looks a lot better. And now I just need to rotate it. So in my case, press the E key, hold the control key, rotate it on the green axis so that it fits your liking. Let me rotate a little further, like so, and it should be good to go. And now the final edge. So let's do that once again. Control W to duplicate, then move it around. You can also hold, by the way, hold the control key while dragging, and it will also snap. So snap it in correctly, press the E key for rotating, or press this button here at the top, drag this green circle, drag it a little bit, holding the control key even further, and until the point where you are happy with the results. So now we have the beginning of our intersection here. Now at this point you might wonder, there's so much stuff already in my hierarchy. Well, that's something that we can fix by creating an empty game object here. So let's create an empty game object. Let's call this one streets here. Streets or roads, something like this. Either way would be fine. And now let's make sure that this piece is reset so that the streets are in the center. And now let's drag all of them in there except for the directional lighting. We don't want it to be there, and of course the main camera neither. And let's drag it into our street. So now we can just close our streets and our hierarchy will still be workable with or viewable properly. Okay, so now let's extend our road a little bit. Therefore, let me, for example, take this road asphalt side piece here. Let me see, is that what I want? Yes, I think this one will be fine. So let me take that. Let me drag it into the game. You see, it's a little off from the rotation perspective. So let me rotate it by 90 degrees, like so. Now let me snap it using the W key, first of all for moving, then holding the V key to now snap it correctly to this corner. Let me see, like this. And then always double check if it is in the right level. So here the Y level should be correct. Otherwise, if it's just a little bit off, you see, then the streets won't be correct. So this looks a little better. All right, now let's go ahead and duplicate this piece. Let's move it over to the other side. Then let's rotate it by 90 degrees. So here, like so. And well, actually 180 degrees, not 90. So like this. Then what we can do is we can take another road piece like this one here. Let's duplicate it and move it over here using the control key while we drag it. This way we are going to snap it. So now what we can do is we can take those three pieces here and we can duplicate them, drag them over holding the control key. So we're snapping them, duplicating once again and dragging, well, duplicating once again and dragging. So this is how we can now create our street pieces, and we could even go ahead, let's say we need more. So let's use all of those here. We could duplicate those, hold the control key and drag it over. So this way we are creating a pretty long street. Okay, now let's just make sure that all of our asphalts are actually part of the street, like so. Okay, so now let's add buildings, and let me see which one looks more like a building. Wall with window, wall B. Well, it doesn't seem like we have a proper building. Let's add this wall garage here. Okay, so let me drag that in there, and now it won't look great because it's not positioned correctly. So first of all, let's press E to rotate it, and then let's rotate it by 90 degrees, like so. Let's make sure that we have the the moving tool, and let's move it over like so. And now let's use the V key in order to snap the corner correctly. Now you see here that it snapped it, but it's not on top of the street, so I'm not super happy with that. So let me snap it again, and maybe even the interior part, like so. Let me snap it like so. All right, this looks a little better. Even though now you might say, let's move it a little further to the left. That could be an option. So here, unfortunately, the snapping tool will not be your friend. So you can, well, you can still snap using the control key, but the V key will not be your friend in this case. Even though, as it seems, they are not entirely the same width here. Maybe they are, yes they are, but then you have to be unprecise with your values here. So something like -12, if you do it manually and the X position seems to be at 7.6, for example, something like that, then it seems to be good. Okay, so either you make sure that the garage is really on top here, or the alternative would of course be that you make sure that the garage is like so. That's fine as well, but then don't forget to also add maybe a garage piece here. So let me snap it over, or I mean street piece, of course. Let me snap it over so that it's underneath here, so that it doesn't look off, because here we wouldn't have anything underneath it. So these are some minor changes that you might have to make after you build your map, let's say with an alpha version of it. All right, and now let's say we want to have this wall painted. Let's drag that in there. Let's use the V key once again, and let's snap it right next to our garage here. And now let's use the wall A with door, this one here. Let me drag it in there. I would like to have the door in front of me, so let me rotate it, press the E key, rotate by 90 degrees, press the W key, move it with snapping, make sure that we snap this edge directly, or maybe even the top edge, that seems to be fine, or top corner. So now we have the garage, we have the door. We could even add a window if we wanted to. So let's see if we have a wall with a window. So here, wall A with window. Let's drag that in there. And let's rotate it by 90 degrees. And in my case, I didn't use the control key. This will be better. So now the W key for moving, move it around a little bit. Now look if the edges are correctly connected. There we are. Let's snap it together. Okay, so we have a wall front now, and now you could go ahead, of course, and design your city as ever you like. Maybe you should also add rooftops here. So a wall roof, either the detailed version or the undetailed version. Let me use the detailed version here. Let's rotate it once again. So here, let's rotate it by 90 degrees like so. And now let me snap it as well. So here, not the rotation snapping, but the movement snapping. So let's use this corner. Let's duplicate this piece. Let's move this over here with the V key pressed, duplicate once again. And now let's use this edge and put it there. And then finally another one, duplicate it. Let's move it over, not with the right one, but with the blue one here, like so. And now let's snap it in correctly, like so. So you see, Unity is really a beast when it comes to helping you with its tools to create this little street here. Now, of course, you have a bunch of other assets that you can use. Fences, you can use the truck here. So let's add the green truck into our game here. So let me put it in like so. It will block the streets, for example. That would be fine. Of course, you can also use it in order to snap it in. So now the wheels will be inside of the ground. So whatever you want. Okay, so that is how you can build the overall level. But now let's look at how we can decorate it correctly. That's what we're going to do in the next video. Welcome back. In this video, I would like to talk about decorations as well as what your map can tell about your game. So it can actually tell a little story even. So let's look at this. So let's look at this truck here, and maybe let's actually drag in this flat truck over here. Okay, so having this, you could expect that some truck owners or some people thought, okay, this is where the zombies are coming from, so let's block them, for example. Okay, so they didn't block this street because they wanted for cars to still be able to pass through here, but they blocked those other streets so that no one can come from their side or from that side. So let's move this truck around a little bit so that it's actually positioned correctly. Something like that should be fine. Now what we can do is we can add some scrubs. So here, let's add a little tree, small, like so. And then what we can also do is we can add a bit of, well, some bricks here. So let's add some bricks in here like that, maybe. Okay, so now you could say, okay, people tried to make a fire here, maybe even, or something like that, where they put together those bricks. Let me duplicate that and something like that. And they try to make a fire in the center here, not with this ground, but more like with this scrub here. So even though this is not perfect, but this is a little bit what you could tell about this map now, or where you could say, okay, now this is where we are creating an atmosphere for our game, where it's not just elements that are in our game, not just game objects, but they actually tell a little story. Okay, so that's something that you could see here. Then we could go ahead and add a little bit of a traffic light here. I don't know what would be the order, something like this probably. Well, not on the street. Let me move it around also using V here. Let's snap it around like so. Okay, this looks a little bit like it, I guess. So that should be fine. Then we can add, where is it? It's further up, I believe. Some barriers here. So let me add this barrier into my game. So here towards the end, maybe even. Like so. Then somebody came along and blocked the street with a barrier, and maybe a second barrier and a third one. So they blocked the street like this. They tried to block it. And then even some stone barriers, you could move those around and try to position them accordingly. Okay, so let me put it in there. Well, this probably isn't that great. Let's also put it behind it in the streets. So let me find a good spot. Doesn't seem like it. Maybe using the control key will be a little better. Okay, so you could now go ahead and build your level like this. You can add cables to your game. They're not very detailed, but let's say people tried to use cables in order to hang something. Okay, so let's reposition this cable like so, and then let's rotate the cable even further using our keys here once again to rotate. Now like so. All right, so yeah, you can see a bunch of options here what we can do. Maybe we can move it a little further even, like so. Yeah, so now there's this cable hanging. Well, yeah, you can see a bunch of options that you have, even with this limited amount of resources that you have here. So the game objects that we have here, it's not insane amounts of objects, but you can still build some cool stuff here. All right, you can even go ahead and add a little bit of a fence here. So add the fence over there. Let's turn it around like so by 90 degrees. Okay, and now let's move it in like that. Let's make sure that we have a ground there. Maybe not a street ground, but maybe dirt instead. So here, road dirt center. Let me add that in there. Let's make sure that this dirt is also positioned well. So here, this edge should be something like that. Maybe underneath. Yeah, this looks a little better. So now we could duplicate this dirt, move it around like so, duplicate once again. Yeah. And step by step, our game is getting a certain shape and looks a little more like a game. Now at this point, you can also make sure, or you should also make sure, that your streets are going to be at your street level. Okay, then your walls, let me also put the walls separately. So let's create a new empty game object in here, create empty, and I don't want to put it in there, but actually outside of it. You see why it becomes difficult to do it via right click? You can still do it here. Create empty. Let me create an empty game object for walls or houses. Something like this would be okay. Or buildings maybe even, instead of houses. Buildings. And now let's put all of those walls in there. Like so, into the buildings. The details, there we could say, and let's create another one. And by the way, I forgot to position it to 0, 0, 0. Oh, that's tricky. Okay, let me go back. Let's make sure that I position it at 0, 0, 0. Let's reset it. And now let's add the walls in there. Let's get them into the buildings. The same for those ones. Do we have any other walls? Yes, I think this one here. And now let's create decorations. Decorations. Let's make sure it's reset here. And now let's add the details in there. Like so. All right. And now this tree small, maybe it's also decoration. Road, dirt center. Well, we could say this is part of streets. Like so. Yeah. Step by step, it looks more and more like a map. Okay. So as you see, you have a lot of options when it comes to how you create your map. And this is actually quite difficult because sometimes you want to build a map in a way where it just creates this atmosphere, right? And atmosphere is created by lighting. It's created by what is in the map and how things are positioned in the map. Okay, so this year, if you put a bunch of bricks next to something, you could assume that they were before maybe on the truck. Okay, so you could duplicate these and put the other ones onto the truck so that it looks like, okay, they were on the truck, then they fell down for whatever reason. And yeah, basically you're painting a story by building your map. And adding these little details will then make a whole difference, which creates a scenery, which can create a bunch of images inside of the head of the player. Okay, so especially in our zombie apocalypse game, this is going to be a very important aspect. All right, so in the next video, we're going to see how we can limit the directions the player can go. And that's going to be something quite important because you want to make sure that the player can't get outside of your game and suddenly fall off or something like that. So see you in the next video. Welcome back. In this video, I would like to talk about some very important parts of your map. And these are the limitations as well as basically just areas where your player cannot get to. Okay, so let's make sure that we take, for example, these parts here and also the roof, duplicate it. Then I'm going to drag those over there onto the other side. I'm going to make sure that I'm snapping them correctly. And now let's actually rotate this whole bunch by 90 or by 180 degrees. So let me see, like this. And it's not actually that working that well this way. So let me just drag it. Okay. So this should be fine now. Okay. So now we have limitations on both sides. And something that you will notice is that if you look at one of those walls that you have here, the buildings, is that they have a mesh collider. So they have a collider, which means we cannot walk through them, which is very important, of course. But now let's create some more colliders here. So what I want is, I want that the player cannot walk past this area here. Of course, the player can jump on top of this stuff that you can see here, but now let's actually limit him. So let's add a couple of trees in here. So I'm going to position them using the move tool and let me put them in here. Then let me duplicate this and put the other tree a little further down there. Another one over here, another one over there. So Now maybe also some tree scrubs like this. Let's make sure that they're positioned at 0, 0. Duplicate, put it next to it. So while this is not perfect, it's still fine, right? So we can go ahead and maybe add another window and house here, or wall with a roof. So let's duplicate this and let's drag those over here. Duplicate once again, drag over there. We can do the same with this garage here. Duplicate, move over there. Duplicate, move over there. So now, of course, here you see we're missing the ground, so we could of course move this ground underneath, duplicate, move it over here, duplicate, move over here. So now it looks a little more like, okay, there's, for some reason now there are trees. Okay, let's make sure that maybe we don't have concrete underneath it, but more of a green underground or green ground. So here, grass, for example. Okay, so let's drag in the grass. Let's make sure that we position the grass accordingly. Then duplicate the grass. Duplicate once again, like so. And let's make sure that it's positioned. I'm going to overlap here. It's fine for this purpose. So now we have grass there. And what we can now do is we can now add a huge wall that will stop us from passing it. Okay, so here let me add those all to decorations, like so. And now let me add an empty game object, and I'm going to call this one wall. All right, so now let's add this wall. Let's duplicate this, by the way, and we can also rotate it a little bit so that it looks a little cooler. Add another one like this, rotate it a little bit, because otherwise it looks like it's just too clean. Okay, so now we have this wall that I created. Let's move it. Actually, it's going to be empty. So let's make sure that we change its Y and X position. Oh, okay, so it's jumping over there. Let's get rid of the Z position as well. Okay, so where I want it to be is, I want it to be over here. Okay, so let me drag it over there, and it will look a little better once I give it a component. So let me give it a box collider here, for example. Okay, and this box collider should be a lot bigger. Okay, so let's play around with the scale here. And the X scale of, let's say 20 should be good here. And the Y scale of 20. So now we have this big wall. Let me move it up, something like this. And let's move it over here. So now we will have inside of those trees, we will have this wall. We can even give it a gizmo. Let's add a gizmo here so that we can actually see it inside of our scene a little better. So now we have this wall. Let's click on it. And this wall should limit the player from walking through. So the player can walk into the trees, but he cannot walk any further than that. So now you could, of course, block his vision a little further by adding some more trees over here. So let's duplicate this tree and let's position a couple more trees in here. It can be a little more random. You can even rotate them if you want to. So let's rotate, well, not this direction, but this direction, like so. Let's rotate the trees a little more so that they don't look all the same. Okay, so this should create an effect where the player, let's assume, so the player is not going to have this flying position as we do, but the player is going to be like at this level. Okay, so that's how high the player will be, and then he will walk over here and he will try to pass through, but he can't. Okay, so he will be blocked by our wall that we just created. Okay, and this is also going to be a good spot for zombies to spawn because the player cannot see where they're coming from, so they're coming from the trees. And let me, by the way, make sure that I'm duplicating the grass down here so that it looks a little better. It doesn't look like the trees are on the gray ground or something like that. Okay, so now if the player who is limited to not go any further than this, for example, you will only see trees. Well, in the background there, you could of course add well, actually in our game, we will have a horizon, which will make it a little better, I believe. But yeah, overall, you see now the player will be limited. He cannot go any further. And this is going to be the spot where suddenly our zombies are going to spawn. And they will come from here. They will maybe pass through the edges here, or they will come from the other side, and then the player has to shoot them. Okay, so this is something that you now have to consider at every single point where the player can run out of your game and glitch through your game, so to speak, glitch through the walls. So really make sure that you build a map which is consistent, but also tells a story, and at the same time has limitations where the player cannot walk through, because your map just won't have anything else to offer. There's nothing cool that surrounds the game anywhere outside of this little map that you're building. And it's even good if you build something that the player cannot access, that is going to look like this is a real map that doesn't just end at the edge where we're walking towards. Okay, so you could build the street further, a lot longer towards this side. You could build more houses here, even though the player might not even see them correctly, and so forth. All right, but that is something that you would now need to do towards all sides. So yeah, see you in the next video. Welcome back. In this video, I would like to give you a little challenge, and that is to actually finish the map. Okay, so please go ahead and make sure that you build your own little map, and always when you make changes, make sure that you save your scene, because otherwise your scene will be lost and the beautiful map that you will have built will be lost. Make sure that you clean up your hierarchy, as I haven't done here. For example, I need to add this to my decorations. Same goes for the grass here. I could actually even put the trucks as decoration in there. And then once I'm done with that, I need to save my scene. So what I would like you to do now is to finish a map, if you feel like it, of course. If you don't want to build any maps in the future and you will always use pre-built maps, or you have somebody else who's going to build your maps for you, then you don't have to learn it. But I would really recommend that you do it by yourself to get a feeling for it. So make sure that you build a little map that looks good. You can, of course, get inspired by our assets that we have here, the city that we built. You can see that this is just one way of doing it. We're limiting the streets here. We have some lighting, we have some sidewalks, we have, well, a bunch of trucks that crashed into each other, some limitations, some more trees. So more of a world that looks like something went wrong here. Okay, and we have two stories instead of just having one story, so a little higher houses. And even here at the top, you can see some iron laying around and so forth. So just go ahead and be inspired by what you see here. Build your own map. Make sure that there are walls, so these hidden walls where the player cannot pass through, as you will see here. Well, if you check out our city, you see this collider here as well as there. So these are colliders that are making sure that there are sidewalks, but the player cannot pass through. Okay, and then there are cables between houses and so forth. So see this as a little challenge. It's fine if it takes multiple hours. It really depends on how much time you want to invest into learning this, into creating a nice map. And once you're done building it, feel free to share it with us. And if you use other assets, even better. These assets are for free, but of course you can use other free assets or even paid assets. Just make sure that the assets that you're using follow the same design language. So for example, now we have these kind of assets which look semi-realistic, but with poor quality, let's say. But then there is low poly, which can look pretty awesome. And if you combine the two, it would look off. So don't make this mix where you're mixing different kind of assets into one game. Quick pause. The video that you're watching right now is just a fraction of the entire FPS course. In the course, you're not only learning how to build a first-person shooter, but also make it a multiplayer game. So you're going to learn a bunch more things than in this YouTube video. It's a 7.5-hour course, and you can not only get the course, but you can currently also get the book with a 50% discount. Definitely check out the link in the description below to improve upon what you're building in this video and become a real multiplayer game developer. So first-person shooters, I think we all know what they are, and we all probably played one at some point. I mean, they've been around since the early 90s with Wolfenstein 3D and Doom. We have our character and we look through his simulated eyes and control his actions throughout a game world. But what is a FPS playable character made of? Well, a lot of games do use the approach of a full body character, using the entire character and animations to represent the player, especially in online focused FPSs, but even there, your main character, so the camera your view is using, almost always only sees one thing. And that is your character's arms and whatever he's holding. Since rendering the rest would just complicate development and worsen the performance of the game. I mean, in an FPS, the only thing you'll see are your arms anyways. A good percentage of games don't even have more than just the arms, especially in action-focused offline games, making development way easier and more dynamic since nobody restrictions are there. Like we see here, in our game, we'll be using the same approach. Since for now, we'll only need the arms, we won't be adding a body. But who knows, that may happen further down the development. In our case, the assets we include have separate meshes with their respective materials in the correct hierarchy. Also included is an animator component and a shoot animation we'll be using, but no animator yet, nor any scripts. So let's start working on it in the next video. Welcome back. In this video, we are going to take care of our main character, our first person character, so to speak. And therefore, as you can see, I have gotten rid of the city that I built in the last couple of videos, and I'm just using the environment here, and that's the city. So just feel free to use your own city. Just make sure that the center of it is going to be at 0, 0, 0. Or otherwise, you can, of course, drag in our city, our environment that we prepared, but also make sure that its position is reset so that it's going to be perfectly in the center of the map. So here, this will be the center point, and from here we can then start with our main character and all of that. So first of all, let's go ahead and prepare our player. Therefore, under assets, you will find your character, and there in the prefabs folder, you will find your first person character. So let me drag that one in there. And you will find that this is what we get, our character. Now we of course need to find a way to make the camera position into the position of the first person player. Okay, so therefore, what you also should make sure, just in case that you have different sizes, I played around with the sizes earlier, and this is something you have to do inside of your weapons, and here in the weapon prefab, just make sure that the scale is set to something around that. So here 0.011 for X, Y, and Z in terms of the scale. Okay, so now our first person player consists of, let's look at him, the FPS character as well as the arms that you see here. Okay, so the arms, they consist of the upper chest with the left shoulder, neck, and the right shoulder. So what we want to do is we want to make sure that this is going to be the view. So we're looking through the eyes of the player. Okay, we only are using his weapon and his arms. Therefore, let's go ahead and drag the main camera into our first person character, directly into the character. In case you get an error here and it doesn't work for you, what you can do is you can make sure that you unpack your prefab, unpack completely, and then you will be able to drag in your main camera. So in case this creates an error for you, that's how you could fix it. So just to make sure that it's going to work for all of you, I'm going to right click and unpack my first person player completely. And then I'm going to drag the main camera into the first person character like so. And that will work totally fine. So now if you look at the game, this is going to be the current view. So let's make sure that our first person player is at 0, 0, 0. Let's reset his position and then let's put him up a little bit. So I'm going to use 1.5 for him. And now let's make sure that the camera itself is also at 0, 0, 0, because now it will be at 0, 0, 0 in comparison to our main character, like so. Okay, so now the camera is directly inside of the player, so to speak, but in my opinion, just a little too low. So let's tune those values a little bit. Therefore, I'm going to use the following values. So 0.35, this is something, and this is not for the city, but actually for the camera. 0.35. So now it's a little higher, which is already good. Then the Y position, I play around with it a little bit, and something around like 0.03 into the negative made it look a little more natural. So the weapon is on your right hand side and your head is a little further to the left. So that's how I envision it. And then the Z position is something like 0.05. So the camera is just a tiny bit further to the front and looks at the weapon just a little bit differently. So now you will see that you have clipping here. So that the player clipped our weapon. How can we fix that? Well, the cool thing is the main camera has a setting and you will find it under projection. Okay, so here the main camera has a bunch of settings that you can set up, right? And the one that we're going to look at is going to be the projection one. And here the clipping planes, that's where you can change the values to get rid of clipping. So I'm going to use 0.01 here, and you will see that the clipping is gone because now it's not going to clip our weapon anymore, and that basically fixes the issue. Okay, so if we run our game, we won't see much because, well, we cannot move now. We cannot play around and move the character and stuff like that. That's fine, because in the next video, what we're going to do is we're going to first of all look at how we can make our character look towards the direction of our mouse. Okay, so our mouse will move around our view, and we will not move the character forward or backward or to the sides yet, but we will at least be able to move his view. So that's it for this video. Now your main character is ready. You can of course go ahead and make sure that you save your scene. That's always a good idea after each video. And we can now make sure that we are dragging our first person player into our prefabs folder. So you can get rid of your old one. That's fine. Let's get rid of it. And let's drag in the new one like so. And now let's save it. And this will now be our first person player that we can reuse anytime. And we also have it available physically. All right. So see you in the next video where we're going to look at mouse look. Welcome back. In this video, we're going to take care of the camera movement using the mouse look. So basically moving our character based on the direction our mouse is. And the logic behind camera movement is grabbing the axis of the input and applying that to the rotation of the, well, usually first child object, and one that contains the model and the camera, but not the root, since that's reserved for movement. All right. So even by using the Z rotation, things like leaning becomes a possibility. Let's start implementing that in a mouse look code. All right. Back in our Unity project, let's go ahead and go to the scripts folder inside of our assets. And here you will find a simple camera controller. What we're going to add, however, is our own script. So let's go ahead and call this one mouse look. Okay, so this script will allow us to look around with our mouse, which is exactly what we want. So now we have to think, what is it that we need? Well, we need to get the input of the mouse, and we need to know the axis. So which direction is it going? Is it going towards the left, towards the right, towards the top, the bottom? So that's something we need to figure out. We need to know how quickly we want to move the player. So we're going to use a mouse sensitivity here, and then we need to transform the player based on that. So we need to make sure that the FPS character's rotation is going to change based on that. So let's get started. First of all, let's set up the update method so that it will get us the axis input of the mouse. So float mouse x, as I'm going to call it, it will be given to us by using the get axis, and here we use the mouse x axis. Okay, so if you recall, if you go to your input manager, you will find the different axis, and the input manager will allow you to modify things. Okay, so you see the sensitivity is set up already, mouse Y is set up. So here we're going to get the mouse X and mouse Y input. That's the X axis and that's the Y axis. And we get them from the mouse itself. So let's use those. So first of all, we have our X position, and we will also need the Y position. So let's go ahead and add that. It will be called mouse Y, and it will get the mouse Y axis. You need to make sure that you write it exactly this way, otherwise it won't work. So now, as I said earlier, we will need the sensitivity, so the mouse sensitivity. So let's create a public float value mouse sensitivity, pretty long name. I'm going to set that to 100. We can modify it later. And now we can actually use this mouse sensitivity to multiply it to our inputs that we get. Okay, so here, let's multiply that to both of them. And now we need to consider that we have this update method, right? And inside of this update method, we want to make sure that this is going to be frame rate independent. So here, let's multiply with time.delta time, which gives us the time that has passed since the last iteration or the last call of our update method. So let's use that for both of them. Now we need to make sure that we rotate our player, and therefore we need to know what we need to rotate, right? So let's get the player using a public transform here, which will be the player body. Okay, so we're getting the transform component from our player body, which we can then drag in. Okay, so if we save the script, we will then find it, well, once we assign it to something like, for example, our FPS character. So let's actually do that. So here, FPS character, let's drag the mouse look script in there. And now we need to define what the player body will be. So you see, we can modify the mouse sensitivity and the player body. So now let's drag the root player into it. So the first person player as the body that we want to rotate. All right, now we can use this in order to actually rotate the player, because right now, if we play the game, nothing will happen because we're not doing anything, right? We're not rotating anything. And that's why we can now use this player body to rotate it. Okay, so there is this rotate method that is available inside of the transform class, and we know that our player body is of type transform. So we can now apply a rotation to the object, to the transform. And I'm going to use vector up here. So vector 3 up multiplied with the mouse X value that I have. At this point, we can save the script and let's check it out. Let's see if we can rotate our player at all. So you see, I can rotate the player, but only in one direction, right? I can only rotate him on the horizontal axis. So let's modify our code so that it will work in all directions. Now, in order for this to work properly, we need to consider something that is called clamping, because we want to make sure that the player cannot rotate down infinitely or up infinitely, because this would create a very unpleasant effect for the player. So not the character in our game, but actual player of the game. So let's make sure that we actually clamp the rotation here, because this mouse Y value is cool and all, but it's going to make us sick if we don't clamp it. So if we don't limit it to, let's say, 90 degrees. Okay, so therefore I'm going to need another variable here. I'm going to call this one X rotation, and I'm going to set it to 0. And then I can set it up here inside of my update method. I can just set it to the minus the mouse Y value, like so. And by the way, if you were to add it, you would get inverted control. So maybe it's useful for some type of simulation type games. So this is how you could set it up here, right? Instead of using the minus here, you would use the plus here if you wanted to get it inverted. So you could even have an if-else statement here, checking the settings of the player, for example, and then depending on that, you could then modify, well, run either the minus equal mouse Y or the plus equal mouse Y. All right, now we need to change the position of our current character, and therefore we're going to get the local rotation here by using quaternion.euler, which returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis. So now here I'm going to pass the x rotation, and for the y and z rotation I'm just going to use 0, like so. So this will only take into consideration this x rotation that we have added. So we call that x rotation, even though it's taking the mouse y value, because we are impacting the Euler float x value with it. Okay, now let's get into clamping. So let's have a look at what clamping does. So what we want to achieve is that we can only rotate 90 degrees up or down. So rot minus 90 for the x value to go up and 90 to go down. So that's basically what we want to achieve, and therefore we will need to use the concept of clamping. So let's take the x rotation that we have here and let's clamp it. And it's as simple as using the math f struct, which has this clamp method. And what this clamp method needs is, first of all, the input, which is the value, and that's going to be our x rotation, and then the limiting values that you want to use, so the minimum and the maximum values. So in my case, I'm going to say the minimum will be minus 90 and the maximum will be 90 degrees. So that's how we clamp. All right, so now that we have the mouse input, that we have the rotation, and we apply this rotation to the transform towards both directions, we're good to go. So let's run this and see how it's going to look like in our game. And we will notice a little challenge here. Let me show you. It will be very obvious in this case. So here, okay, I can move, and you see my mouse is moving outside of the screen, which is not very pleasant. So it's not very easy to manage this way. Also, the speed is, in my opinion, too slow, but this depends on your mouse settings. So it highly depends on your mouse settings, actually. I'm going to change the mouse sensitivity to, let's say, 1000. And let me run it once again. And now I'm good to go. Okay, so now I can rotate. I cannot move the player yet, but I can at least look around. But now let's fix the problem that our mouse is leaving the game scene, or this game view. In order to fix that, there's one very simple line of code that you can use, and that is cursor.lockState is equal to cursor.lockMode.locked. Okay, so this cursor locked mode is an enum which has multiple states. It's either locked, let's look at it actually, none, locked, or confined. And in our case, locked is what I want to have. So here, making sure my mouse doesn't leave the game window. All right, let's save this script and let's get back to Unity and let's run it. And now you see I'm locked in the game. My mouse is locked. I can use the escape key in order to get out of it. But once I click into it, again, my mouse is locked again. Escape in order to get out of it again. And then stop the execution. Now let's maximize on play. So that's going to look a little better because it's bigger. So there we are. Now I can play my game. And I cannot shoot yet. I can run yet, but we're going to take care of all of that step by step. So see you in the next video. All right, so now let's make sure that our player can move. And Unity has an integrated input being the horizontal and vertical axis. These return certain values depending on the key press. When we press the W, the vertical axis will return 1 or -1. When pressing the W, the vertical axis will return 1 or -1 when pressing the S key. The same goes for the horizontal axis with the A and D key. It's pre-set up also to work with gamepad, so you don't need to take care of that separately. Alright, so back in Unity, let's go ahead and take care of player movement. Therefore, I'm going to create a new script. Inside of the scripts folder, it will be the player movement script. Alright, so let's take care of that. We have done player movement before. It will be very similar. There will be some minor changes, however. Okay, so as always, we first of all need to get the input, and I'm going to get the X and the Z coordinate from the axis, horizontal as well as vertical. We have seen the input manager before, right? So we are just getting the AWSD keys as well as the arrow keys. Okay, so this will be left and right, or A and D, and this will be W and S, or up and down. So we get those two, and now we can use those in order to move our character. So let's create a 3D vector, which will be called move in my case, and it will get the right position multiplied with X. So whatever we defined here as X, so whatever we added for the horizontal direction, we're just saying, okay, move the player towards the right multiplied with X. So if X is negative, then he will not walk towards the right, but he will walk towards the left. So this is the red axis of the transform in world space. So it will just move the player towards the right. And now we need to make sure that we are also adding a little bit of a twist so that we can not only walk towards the right, but we can also walk towards the front. So let's use transform forward and multiply that with Z. And this will create this 3D vector, which will now know in which direction the player should move. Now we can use this in order to move the character. But how can we move the character? Well, I don't want to use a rigid body here where I make it move based on physics, but I want to make sure that the player just walks without physics. Okay, so with a constant speed, so to speak, and disregarding physics entirely. What we need to do, therefore, we need to move something called a character controller. So let's go to our first person player, and here let's add something called character controller, this one here. So this character controller, as you can see, it has a slope limit, step offset, skin width, and so forth. And what it gives us at the same time is going to be this physics body, okay, this collider surrounding it. So we can change the collider a little bit. I'd say let's tweak those values just a tiny bit. The Y value should be a little lower, so 0 dot or -0.35, so that it's a little lower. Should be good to go in my opinion. Now you can of course play around with this value as you like. Okay, so let's get back to our player movement script, because here we now need to get this character controller. So I'm going to create a new variable here called character controller, which I'm going to call controller, like so. And now let's use this controller to move him. Okay, here in our update method, we can now move the controller. So as you see, this is a move method that the character controller has to offer, and a more complex move function taking absolute movement deltas. That sounds amazing. And we need to pass the vector that we want to move towards. So let's just move it towards our vector 3 here. Now this would move the character, but how about also making sure that we can modify the speed of the character? That's always a good idea. I'm going to start with a value of 12 here as the default speed. And now finally, let's make sure that our move here, so this is the vector that we're using, is also going to be impacted with the speed as well as time.delta time, so that it's going to be time or frame rate independent. So our game will, or the player will be the same speed no matter on which device you're using it. And now at this point, let's save the script. Let's go back and let's make sure that our first person controller or first person player gets the script. So let's add this player movement to it. And now let's add the player or this character controller to it at the same time. We can also make sure that we apply all of those changes to our first person player, as well as save our scene so that the scene is not going to be lost in case Unity crashes, for example. And now let's see. So I can now move around. I don't have a jump key yet, but I can already move around in my game, and it looks pretty cool, I'd say. Well, getting stuck, that's good. Well, not good that I get stuck, but as you see, this game works. So I'm not really good. I'm pretty fast here. The sensitivity is maybe even too fast for me. I'm not a big fan, so I'm going to tweak the sensitivity here. Let's use 500 instead. And that's how you can tweak the sensitivity in your FPS character, right, in the MouseLook script. And the first person player will take care of the movement. So the FPS character is taking care of the direction we're looking at, and the first person player is taking care of the actual movement. All right, that's it for this video. See you in the next one. Welcome back. In this video, we're going to fix the gravity problem, because if you tested your game a little bit, you will have noticed that if you step up on something, that the game will push you up, so it will let you move up a little bit, but then you will stay up. So it doesn't pull you down anymore. So your character is floating in the air, so to speak. And as you can see, there's no gravity. So we went up, but we don't go down. And in order to change that, we are going to take care of gravity, which is basically a force added to an object over time with a value depending on a given gravity number, making it exponentially grow in speed until it reaches terminal velocity. Implementing it would be moving our character down with an increased velocity. So let's add that to our script. Therefore, let's go back to our player movement, and let's make sure that we have a vector3 velocity here, velocity, like this. And I'm just going to leave it at empty for the beginning. And then I also will need the gravity. So I'm just going to use the default gravity that we have on Earth. So float gravity of 9.81 F, which is 9.81 meters per second square. That's how the velocity or the gravity is on Earth. So that's how fast items accelerate, so to speak. Okay, and now what we can do is, here in our controller player move, here we can make sure that our velocity is going to also have a y value that will take the old velocity plus gravity times time delta time. So just making sure that it's going to work correctly inside of the update method. Now to actually add that to our player movement script, we need to go ahead and say controller.move. And here we are going to move with the velocity also. And because physics tells us to calculate increasing velocity in a free fall, we need to multiply gravity by time squared. To do that here, we need to once more multiply our velocity by time, because velocity is already meters divided by seconds. If we now add the time delta time, then we are going to divide it by seconds squared. So this will now give us the right timing here. So that's going to be the gravity. That's how you can implement it manually without using a rigid body and all of that. That is definitely going to be relevant for our game. So let's run the game. And let's see if we can fall down again after we have walked up something. So you see, gravity is pulling us back down like this. All right, so that is pretty much it. Now you know how to add gravity to your game. And our only issue is that velocity just keeps increasing indefinitely as if we were in a constant free fall. But we obviously aren't. So let's add a way to let our scripts know that we are indeed on the ground. Therefore, inside of our player character, so inside of the first person player here, not the FPS character, but the first person player, let's create an empty game object. I'm going to call this one ground check. While we're at it, we can also give it a little bit of a gizmo here, because otherwise we won't see it properly. Let's also make sure that ground check is going to be at 0, 0, 0. And here for the Y position, it shouldn't be inside of the player, but maybe a little further down. So minus 1.4 should be good, because now this square will be inside of the ground, so to speak. Okay, because our character, if we look at it here, it's at 1.5, so it will be just at the edge. We can play around with this value later if we're not happy with it in the end. So for our ground check. Now let's go over to our player movement here, and let's add another variable here. Public bool is grounded. So this one will know, or will indicate whether we are grounded or not. So inside of the update method, we can use a cool method here. So is grounded, we're going to set that to physics dot check sphere. So what that will do is returns true if there are any colliders overlapping the sphere defined by position and radius in world coordinates. So let's just do that. Now this check sphere isn't very happy, because you see it needs a position, a radius, a layer mask, and then there are multiple overloads that we can use, but we're going to use the one with those three. So we need to set those three up. So let's create, first of all, a transform, public transform. Going to call this one ground check, then a ground distance. So here ground distance, which will be, let's say 0.4f. We can also play around with this value, and then we need to set the layer. So here public layer mask that I'm going to call ground mask. So this layer mask, by the way, specifies layers to use in a physical raycast. And this layer mask will allow us to know which layer we are at. So now we need to pass those values. So let's pass those values here. Ground check dot position, then the ground distance, as well as the ground mask that we just set up. And then the check sphere method will be happy. So now what we can check is if is grounded and the velocity towards the y coordinate is less than 0, then let's run some code. So what we want to do here is we want to change the velocity of y to be minus 2f. This will give us a small landing transition of some sort. Okay, so it's not like we are going to have no velocity towards the y coordinate at all. This will make the grounding process a little smoother, because in the next video we're going to see how to jump as well, and this is a little trick to make it a little smoother. As well as pressing the player to the ground removes the possibility of floating, because we really want to make sure that we're not floating. All right, now let's save this script, and let's make sure that our first person player here has a certain, well, let's apply the changes that we made. And now let's look at the layers, because so far we have not really used layers, right? But there is on one hand the tag, but then there is also the layer. So the transparent FX layer, water layer, UI layer, and we can now add another layer, and I'm going to add it here on the layer 6 position, and I'm going to call this one ground. Okay, so this ground will now be my new layer. Let's make sure that we add that here. And now back in our first person player, we need to make sure that the mask is using the ground setting here. So the ground mask will use our new layer that we added, the ground layer here. So let me use ground once again like this. So now here we need to make sure that our street is going to be the ground. So only if we are on the street, we want to use this ground layer. Okay, so really make sure that we change the children here. Okay, we need to make sure that all of the children inside of my street have this layer ground to them, because now if we are on the ground, we know that we don't need to fall further down, so we don't need a velocity that pulls the player down. Okay, so that's one way of doing it, of course. So you see, when you're not using rigid bodies for movement and for physics, there are a lot of extra steps that you need to take. And now we just need to make sure that the ground check that we're using here is added to the ground check setting. So here the ground check of our main character, this extra component that we created. Let's make sure that we are dragging it into our first person player ground check property here. By the way, make sure that the player itself has a default, right? We just added the ground, but we don't need the ground layer for our player. We really just need it for the streets, okay, in our city. Now you also might want to add the ground layer to other items that you want to be able to jump on. For example, those blocks here, or for example, also the vehicles that you have here, the decorations like such as the cars and stuff like that. So add the ground layer to whatever you want to be able to jump on and not use gravity dragging you down for. So let's test this. Let's see if we can actually now be pulled down properly with the right gravity. Well, we have the smooth effect, I'd say. So it feels smooth how we're dropping down. It doesn't feel super off or anything, right? Okay, and now let me check it without maximize on display. So here you can then also check your character out and see the Y value here. The position is at 1.43, and you can see we have a little bit of gravity pulling us down like so. And in the next video we're going to see how we can use jumping, and then you can see the gravity in action even better. So see you there. Welcome back. In this video we're going to take care of jumping, and therefore we can use the axis called jump. So here there's this jump axis. It's going to work in a very similar fashion as we have seen with the horizontal as well as the vertical axes. But now we're actually going to use the get button down method to get the jump button. So the cool thing is we don't have to specifically define what the jump button is because, well, it is defined in here inside of Unity directly. So let's go over to our scripts, to the player movement script. And we have one big advantage because we have already taken care of this is grounded boolean. Okay, so we already know when we are grounded, and this allows us to only jump if we are grounded, which is perfect. So let's go ahead and in our update method add the following line of code. So we are going to check if the input get button down is going to be jump. So I have to write it with a capital J here, and if the player is grounded. So only if those two things are given, I want to make the player jump. So in here, I could do something like velocity Y is going to be 10. So now we have a velocity that will push the player up by 10. Okay, so let's test this. Let's save the script and quickly check if we can jump in our game already. And let's check it out. And there we are, we can jump, even though we jump way too high, I would say. So this is something that you can definitely now play around with. You can test what you like most in terms of which jump height you want the player to be able to jump towards. So I can even jump onto this truck here and potentially even jump onto houses, which is super tricky because then our player could easily glitch the game by jumping on top of one of those houses and then, well, get out of the map, so to speak. Okay, and we want to avoid that. All right, so that's something that you definitely need to test every time. So let's get out of it here. And now what I would like to do instead, however, I would like to use a method here which will give me the jump height times the negative gravity. Okay, because gravity is pulling the player down and I want to push the player up. What I'm going to do therefore is I'm going to create a variable so that a game designer could then play around with those values, or we can play around with those values later by using float, jump height, and I'm going to use 2f here. So I'm just going to say I want to jump up twice the gravity, but in a slightly more complex manner. Okay, so here we have this gravity, which is created here. But now let's do something similar here where we use the gravity also, but the function is a little more complicated. So what we're going to do is we're going to say that we want to use the square root, so math f.sqrt, which gives us the square root of the jump height multiplied with 2 times the gravity, like so, and 2 times negative the gravity. So jump height multiplied with twice the negative gravity. And from that, we're going to get the square root. So this will give us a rather good velocity, I would say. And the designer can then play around with this jump height value and modify it. Okay, so let's save this script now and test it. So there we are. Let me jump, and you see the jump seems to be all right. So this is not an insanely high jump this time. It looks a lot like a more realistic jump in a game, I would say. So you can jump up this truck here, but only at this point. So you cannot jump to the top of the truck. Maybe you can bug yourself up there somehow, but it doesn't seem like it. Okay, so now we have added our jump feature, and in the next video we're going to look at the animations and setting up the animator. So see you there. Welcome back. In this video we're going to add the zombie to our game, and we're going to look at the animator first. Okay, so let's go over to our Tutorials EU assets. In the assets folder you will find prefabs, and there, for example, the zombie. So let's go over to our scene view here, and let's add the zombie just in front of our player. So somewhere around here should be good. Let me also turn it around by 180 degrees, something like this. And then if we look at it, there is our enemy. So there's the zombie. So let's start the game. Let's look at the zombie, and you see the zombie doesn't do anything. It just stands there in the T pose. Okay, so this hands out pose is the T pose because it looks like a T, right? So now what we can do is we can go over to our zombie and check out what the zombie is made of. So the character medium here, for example, has the mesh renderer and the material. So the character medium is just the appearance of the zombie that we have here. The zombie game object is just the parent game object that contains the appearance, as well as the root, which contains the hip, the left foot, and the right foot control. Okay, so what you can also see is that your root has an animator. Okay, so if it had no animator, for example, if you, for example, only had the appearance of a zombie, you could add your animator manually. So you can just go ahead and add an animator this way, like this. Okay, but I'm just going to revert the changes. And now this animator component that you have inside of your game object needs to have a controller. The structure is always you have your game object that has an animator. The animator needs a controller. The controller needs to have animations that it needs to execute. Okay, so we're going to build this up step by step. In this video, we're going to first of all add a new controller. Therefore, let's go ahead and go to our characters folder, and here under animations, you will find a bunch of animations, and we are going to adjust those later on. So these are animations. You will see where to get animations later. And these are controllers. So we have the FPS Controller, which is an animator controller. And then we have another one here, which is the zombie one. But we're just going to create our own now. So let's create a new animator controller. So right click into the animations folder, and here you can create a new animator controller. So let's do that. And let's call it zombie animator. So zombie animator. You could of course call it zombie animator controller, but zombie animator will be fine as well. So now let's open this up, and what we will see is something similar to what we have seen before when we created our Space Invader clone. Okay, so we have the entry state and we have the exit state of the whole animator controller, but we're going to now add different states which then allow us to run certain animations. As you see here, we have a couple of animations ready. So the zombie idle as well as the zombie walking. And you can also download the zombie run animation that we're going to use. You can even double click on it and you will see what's going on in this animation. So the zombie run is quite a long animation, as you will see. So there's a lot going on. You have the hips control, you have the left up leg, you have the right up leg. So a bunch of individual body parts, and each of those goes through a certain movement, okay, certain animations. So every frame there might be a difference, for example, for this hip rotation that happens. But we're going to look a little more into that a little later. So for now, let's look at where we can get animations from and how they work. So animations are essentially a set of instructions for the correct movement of what's called bones during a set time. Think of them as literally every other animation from shows or movies or, well, your favorite video game. It's what basically makes the characters move. So they can be handmade, like these ones, where a character gets a set of bones created and then animated, moving their body part frame by frame, creating key positions. So you tell an object to be in a specific position at a specific frame and moving it to the frame in either an interpolated or a non-interpolated way. In other words, smoothly over time instead of instantly. So another option, which is what we are using today, is to use other available sources of already made animations, be it community made like an open game art org, or using advanced tools like Mixamo, which is where we get our animations from. So it's this one here. The latter one being just an amazing tool that lets you get characters and animations for free. You can use them even letting you import your own model and an on-site auto rigger. We went ahead and already went through this process and added the animations to the included assets. But if you want to try it out, don't hesitate to visit the page and do it there. So now let's quickly look at Mixamo and then in the next video get started using those animations. So there is this page called mixamo.com. You can sign up for free and then you can find characters as well as animations. So here you have all of the different characters that they have to offer for free. Even Jill, which is a zombie or one kind of a zombie. You can see here, Jill doesn't have the mesh assigned to her. At least that's not loaded, but you can see how she's going to look like in a T-pose. Then you have the skeleton zombie T avalanche, and you can then add animations to it. So there is our skeleton zombie in its T-pose as well. You can now find animations. So here, and then just run a certain animation. For example, capoeira. So now you see the zombie doing capoeira. So you can change the posture. And actually, you see after a while, the mesh is also loaded. You can change the step width in this particular animation. So now the steps won't be as wide. You can play around with the different presets that are here. So overdrive is the speed here. Then the character arm space in this particular case is relevant. So really play around with it to create whatever animation you want. So for example, sitting laughing, you will have different kind of settings here. So here the funniness. If the funniness is insane, then the character will laugh a lot more. You see here, like he goes really insane and laughs quite a bit here, going crazy. If the funniness is less than that, you see he just laughs sitting there and not going too far back. So you can really play around with those values, and you see there are tons and tons of animations. So here, sword and shield back. Looks like a pretty cool animation here. Even though in our case, our character doesn't have a short sword. So we have to, well, basically also move around here. So you see, you can even follow the character using WSD or WASD, and you can see how your character will be moving with this animation. It's a very long animation. So there are 49 animations in total for this one animation combo, so to speak. But it looks freaking awesome, in my opinion. So then there's also the Capoeira pack, which also contains a bunch of different animations, not just one. So yeah, I think you get the gist, you get the idea of it. So Mixamo, amazing tool. You can find a bunch of characters for your games. You can use them. I think they even say that, well, the rights are reserved by them, but you can still use them. so you can still use them in your game. I think you don't have to pay anything for it, even though I would definitely double check that in your case. If you want to know more about it, check out the terms of use. Yeah, then you have all of those animations, and you see I'm scrolling down and there are 52 pages with animations: jab cross, idle to push up, injured walk left, and so forth. Even here for archers you have animations: walking back as an archer, sitting in disbelief, female animations, and so forth. Okay, cool. So let's go ahead and use some of these animations in our game. So see you in the next video. Welcome back. Let's actually use our animator controller in order to set up some animations. So go to your zombie animator here, the animator controller, so animator.controller, and then you will find this empty animator. You should be on the animator window at this point, and here you can just go ahead and create an empty state. So let's do that. Let's call this one zombie run, like so. Now it will be called zombie run, and now let's add the zombie run motion to it. So here you can drag in the motion, or you can select it from here. So I'm going to use the zombie run motion. Now let's go over to our zombie, and there in the root, let's make sure that we are using our zombie animator here. So you can drag it into your zombie animator controller here, and then let's go over to our game and run it to see whether our zombie is now in fact running. So you see, well, it ran at least for 1 frame, but then it stopped running. So it was a little too fast for us to see it, and that is because it doesn't loop yet. All right, now instead of making him run for a short second, as we did here, so you see he ran for run iteration and then stopped. So instead of making him run, let's get rid of this. Let's create a new empty state, and let's call this one idle. Idle means nothing to do. So the zombie doesn't have anything to do. He doesn't have to run. He doesn't have to jump, none of that. Okay, so let's add the idle animation here from our animations in here. So zombie idle will be the motion. So the animation, the motion for our idle state. Now what you can also do is, instead of creating a state, you can directly drag in one of your animations. This will create a new state for you. So now we have the zombie run animation. You see the motion is directly there. In our zombie animator, what we can now do is we can now go from the idle state to the run state. So the zombie will first be idle and then it will run. So you can right click into your idle state and make a transition to your zombie run. So what will now happen is it will go from the entry state to the idle state, where it will run the idle animation, and then it will go to the run animation. So let's quickly look at that. You see, first the zombie is idle and I'm just too fast. See, idle, idle, and then it starts running. So the game is not frozen, it's just that it ran the idle animation once and the run animation once again. I'm going to leave the mouse alone. So now you see this is the idle animation. Let me go down a little bit. Idle, idle, and then run. Okay, so that's what our animator is doing for us. So first running the idle animation, then running the zombie run animation. Now what you can do is, if you want to see this a little better, well, you can zoom in. That's one thing. You can go to your zombie animator and actually, to really make sure, click on the zombie animator controller here. Click onto it and run the game. And you will see how the idle animation is running, and once the idle animation is done, you see the zombie run animation starts. So that's how you can see at which state your game currently is. So I'm going to drag the animator back here so I can see it in a better format, so it's a little bigger. You can use a middle mouse button in order to move around easily inside of your animator. Now let's look at parameters, and we have done that before in our 2D game, in our Space Invader game, because we can click on this transition and we can see that we have certain conditions here. So we can say what the condition is for this to run. As we currently have no condition, after the idle animation is done, it automatically jumps over to the run animation. So let's go ahead and add parameters here. So here at the top left hand side, you can move between layers and parameters. And I'm going to go over to parameters. I'm going to create a new Boolean here. And I'm going to call this one is running, like so. And maybe I should call it is running with a lower I, like so, is running. And now what I can do is I can click on this transition and I can select conditions. So here, click the plus button and you will see is running will be selected. As we have no other options here, is running is going to be the only one. And I'm going to set that to true. So once is running is set to true, so this tick box is checked, then the transition will move from the idle to zombie run. So let's deactivate it by default. Let's go over and make sure that our animator is on the side next to our game. And then let's move over a little bit so that we can see it a little better. Okay, so now we have our idle here. Let's start the game. It will go over to idle, but it will not start the run animation, even though idle is done. Okay, idle is done. And then it's going to do idle once again. Let me click on the running. Let me move over here. Let me is running. Click on to that. And you will see once the idle animation is done, it will start running. Okay, so now this condition is met. So this condition that we had set up here is now met. And that's why our transition can be executed. So here, our make transition that goes from idle to zombie run. You may also have noticed that it takes quite a while for the idle animation to stop and is running to be executed. So let's run this once again without having this has exit time activated. Because you see here, there's an exit time, which is pretty long, 3 seconds until there's the transition from the idle state to the running state. Okay, so let's deactivate this has exit time. Let's run it once again. Now let's see, our character or our zombie is in the idle state. All right, and now let me click on is running. You see it starts running straight away. So this time it doesn't wait for the idle animation to be fully done because it has a certain exit time. It means it needs to finish the idle animation before going over to the zombie run animation. I created an extra video on that in our Space Invader example where I explained the has exit time in more depth. In the next video, we're going to add a couple more transitions in order to also go back to the idle animation after the character has run. Quick pause. The video that you're watching right now is just a fraction of the entire FPS course. In the course, you're not only learning how to build a first-person shooter, but also make it a multiplayer game. So you're going to learn a bunch more things than in this YouTube video. It's a 7.5-hour course, and you can not only get the course, but you can currently also get the book with a 50% discount. Definitely check out the link in the description below to improve upon what you're building in this video and become a real multiplayer game developer. We are going to take care of the transition back from running into idle. Okay, so let's go ahead and click on zombie run, and therefore we can also make sure that our animator is going to be full screen here. So I want to move from zombie run to idle, therefore I need to click on zombie run, make a transition, and you see this transition pops up, which also can snap towards where it fits. So for example, into the idle state. So let's click on this transition. What I want to make sure of is that my transition from zombie run to idle is going to be connected to a condition. So only if it's running is set to false, I want to make sure that the idle animation will be running. Okay, so we're going from zombie run to idle if the condition of is running is set to false, and the other way around, we make sure if the idle animation is running and then the is running Boolean here is set to true, that it jumps over to the zombie run animation. So what I'm going to do also is I'm going to get rid of this has exit time because I wanted to transition very quickly from running to the idle animation and the other way around. Even though this might look a little off in some animations, or it could look a little off in some animations, it shouldn't be too much of a problem in our particular game. But if you want to be super precise, you definitely need to take the has exit time into consideration for some of the animations that you're going to use. So now let's test this and let's run our game here. There we are. Let's move over to is running. So I'm going to click on this is running here, and we are going to see that our animation, well, our running animation went through. It's a little difficult because my mouse is being connected to the game as well. So here, let me deactivate it. You can see it goes back to the idle animation and runs through it again and again. I go to running. It runs through the running animation and back to the idle animation. Okay, depending on whether I activate it or not. You see, it really goes very quickly. So the animation is very clean. All right, so that's it for this video. In the next video, we're going to start looking at the enemy controller, so the enemy manager, which will take care of the AI. So see you there. All right, so now that we have a general idea of animations and animators, let's make sure that our enemy can actually run after us. And we're going to do that within a couple of videos. So the first thing that I want to make sure is that my zombie has a script that will take care of the zombie following the player. Okay, so let's go over to our assets here. Let's create a new script, and I'm going to call this one enemy manager. So here, enemy manager. So it's going to manage our enemy. So let's check this script out. The only thing that I'm going to do for now is going to make sure that our enemy manager finds the player. So let's go ahead and find the player based on his tag. And this is actually something that I would like you to try to do yourself. So in the start method, please assign the player game object using the method that will find the player based on his tag, on the player tag, so to speak. Okay, I hope you tried it, and it's going to be basically this here, where we assign the player game object based on find game object with tag, and then it will find the player with the player tag. So let's save this script and let's get back to Unity, and let's actually make sure that our first person player here has this tag assigned to him. So you see here the first person player has this tag player, and our zombie, if we look at it, needs this script now. So let's add this script to the zombie, this enemy manager in here. Let's also make sure that we are applying all changes to the zombie, everything that we changed with our zombie here. Let's save the scene while we're at it. And now you see that the player is an empty game object before we start the game. But now let's start the game and see if that's going to change. And we can see it changed to first person player, which is exactly our player. So it's great. So it's working. So it finds our player based on this one line of code that we added. So this find game object with tag here. Okay, so now we can use that for the zombie to run after us. But before we can do that, we need to make sure that it actually knows where to run. So we need to give it a certain, well, instruction. So it needs to know what the ground is and where it cannot run towards, so that it cannot run against the wall, for example, and those kind of things. Therefore, we need to look at the nav mesh as well as the nav agent, which is what we're going to do in the next video. So see you there. Welcome back. In this video, we're going to look at what nav mesh and the nav agent are before we're going to actually implement it in our game. So the nav mesh, or navigation mesh, that's the different name for it. So the process of creating a nav mesh from the level geometry is called nav mesh baking. So the process collects the renderer meshes and terrains of all game objects which are marked as static, and then processes them to create a navigation mesh that approximates the walkable surface of the level. So here you can see that this is the nav mesh, so everything that is blue here is walkable, so to speak. So you can see the enemy cannot walk into posts, it cannot walk into trees, it cannot walk on top of, for example, houses or into houses. So it can only walk on this blue surface. And it could walk on top of houses, as you see here as well, because they're great flat surfaces, but it cannot walk on certain other areas of the map. So once you have a nav mesh baked for your level, it's time to create a character which can navigate the scene. And this is done using a nav mesh agent component. So there's this new component that we're going to assign to our enemy, and then the enemy will know where it can walk on. And this lets Unity know that the game object similar to the character controller can navigate through our scene and gives us useful methods to use. So let's use them to make our zombie move and follow us in the next video. Welcome back. In this video, we are going to use the nav mesh in order to prepare our world, so our map, so to speak, for our zombie to be able to walk in it. And therefore, we're going to use the nav mesh that we can find under Window AI Navigation. So here you will find this new tab, which is called Navigation here, and it has this bake option. So this tab that is called bake. Now here you can change up a couple of settings for your agent. So your baked agent size, for example. So what you can see here is that on one hand, the agent has a certain radius. So how thick is the agent? For example, if the agent is super wide, then it cannot walk past certain areas of the map because it's too narrow there, for example. Then the same goes for the height. If there is an object blocking at a certain height and the agent is taller than that, then the agent cannot pass this area. Then we have the max slope, which means the angle which our enemy can walk, for example. So if the slope is too high, then the enemy cannot walk past this area. If it's super low, then he can still walk past it. And here we can define what the maximum slope is that our agent can still walk. So if you have a map with hills and stuff like that, then you could define here which areas the enemy can still walk, so which kind of height he can still progress in terms of angle and what he cannot walk past. Then you can define the step height, so how high are the steps that the enemy can make, so the agent can make. So let's say 0.4 meters in this case is how high an enemy can still walk. So for example, here you can see that there is a certain height that our pedestrian walk here has. So if the step height was 0, for example, then our enemy could not walk onto this pedestrian height. So that's something you need to take into consideration when it comes to the step height. So we're going to pretty much leave everything as it is. You can see you can even define the jump distance. So if the enemy can jump, for example, or how high he can drop, how much he will be, well, able to drop before the mesh will not consider it as a walkable option and so forth. So I would say let's just leave it as a default. And here you will find the bake button. Okay, so we can bake our nav now, our nav mesh. But before we do that, let's actually make a couple of changes to what we want to even be part of our nav mesh. So what I'm going to do is I'm going to make sure that my invisible walls and woods are deactivated. So here, let's uncheck them. Okay, and then I make sure that everything else, so my streets, my blocks, my buildings, and decoration are set to static here. Okay, so here you need to make sure that all of them are static. You can change the children. So I'm going to deactivate it so that they are in fact going to be static, because the nav mesh can only bake static game objects. So things that will not change, they will not move, they will not be influenced by gravity or by physics or anything like that. They will be static. Okay, so we make sure that all of these fields are static, but invincible walls and woods are not. Okay, so if we look at it, we can also make them unstatic here. Okay, so now why am I deactivating the invincible walls and woods? Well, that's because I want my enemy to spawn here. So I want my enemy to spawn, let's say, somewhere where we cannot reach as a player. That's why we have these invisible walls, because we shouldn't be able to walk past this field or this area to, for example, leave the game. And that's why we also have these woods, so that they block the vision. But our enemies, they should in fact be spawning just behind those trees, for example, or behind this wall here, because we cannot see where they are coming from, and this makes the game feeling a little better. Okay, so it would be weird if they just spawn out of the blue somewhere where you can see where they come from. So you can use this little trick where you just spawn them somewhere where you cannot go and where you cannot see through, and then they come from this area. So from this behind the trees area here, for example, or behind those trees, or behind, well, these trees here and so forth. So we can later on make sure that we have spawn points that are somewhere where the player cannot see and where the player cannot get to. Okay, so let's make sure we deactivate those two again, so the invincible walls as well as the woods, and now we can actually bake our city. Okay, so now we can go over to our navigation here and bake it. So let's click on the city, or actually we can just click on the elements that should be part of the nav mesh and then bake them. Once you click the bake button, depending on your hardware, it could take a little longer, but overall this is what we're getting. So all of this blue area is where our enemies can now walk through. So you see there you have a certain width, which is why there is an area here around this post which is still being considered that the enemy cannot walk past it or next to it. But that's overall now going to be the area where our enemy can walk. The enemy can even get up here, well, potentially, if this is 0.4 height. So the steps height is at 0.4. Okay, so now we have the areas where our enemy can walk, and you can play around with those fields here, as I said. So for example, if we change the step height, you can see now it can get to certain other areas that it couldn't get to before. I'm going to use 0.4 here to bake it and make sure that that's going to be the default setting for our agent. In our case, it will be the zombie that will use that. So now we have a nav mesh that is active. We have used the nav agent for its size and all of those settings. We can deactivate the display here, show nav mesh. We can deactivate it anytime, but if we go to the inspector, it will be deactivated either way. So now let's make sure that we activate our invisible wall and, well, walls and the woods again. And now we should be good to go for the next step, where we're going to make sure that our enemy can follow us. So see you there. Welcome back. In this video, we are going to make our zombie actually follow us. And we can do that by giving him a nav mesh agent here. So let's add a component to our zombie. Click on the zombie, go to the add component button and select the nav mesh agent from there. You can just search for it and then add it. So the agent type will be like a humanoid, and you can see it has a certain speed, an angular speed, so how quickly can it turn, an acceleration, so how quickly can it accelerate, and so forth. The interesting thing here is obstacle avoidance are the things that we have seen with our nav mesh agent before, which was that it had a certain radius, a certain height. So it's pretty much the same thing that we can see here. So it will auto repath, it will auto traverse off of me. So it has some pathfinding in it as well. So now we can overwrite our changes that we made to our zombie prefab, and we can now go over to our script in order to make sure that this nav mesh agent actually does something, because currently it won't do anything. We need to make sure that we add the AI namespace here. So Unity agent.ai. And then once we have that, we can go ahead and get the component called nav mesh agent. So nav mesh agent. And then it has this property called destination. So the destination, if you hover over it, it will say gets or attempts to set the destination of the agent in world space unit. So what should be the destination of our enemy? Well, I would say it's the player. That's why we created the player here, right? So how can we get the position of the player game object? I hope you tried it yourself and you paused the video. So we're just going to go ahead and use the transform.position here of the player. So player.transform.position. So this will give our nav mesh agent a position, which it needs. It needs a 3D vector, and position is a 3D vector. So now our enemy will update every single frame, or will try to walk towards the player every single frame. So even if we are changing our position, it will constantly update the position. Okay, so let's go ahead and see if this is actually going to work. Let's see if our enemy, our zombie, is going to follow us. And there we are, it tries to follow me. So you see it's walking, it has a certain speed. Of course, the animation is a little off still. Let me walk past it. You see it has a certain speed at which it can rotate. Okay, so this is the angular speed that we have set up at 120. And if we were to change that, it would be a little faster at changing. But you see, the zombie is running after us. We cannot shoot it yet because we haven't implemented shooting, but at least the zombie is running behind us. And let's go onto the truck here, for example. Let's see if we can get us there. So you see, he cannot get us here. That's why he stopped running after us. So once I'm at the ground again, you see, it runs after me. If I'm in the air, well, it can still reach me, but as soon as I'm up here, it cannot reach me anymore, which is now a blind spot in our game. So now we could make it so that the zombie can still reach us by either giving him huge legs or the capability to jump or climb or whatever, or we could add a little bit of a slope here or like a little path that the zombie can still walk in order to get up here. But then we would have to bake our nav mesh. Okay, but that's it for this video. So now you see how you can make sure that your enemy is following you. And then the next video, we're going to see how to add animations to our enemy so that it follows us. So see you there. Welcome back. Let's make sure that our enemy is now going to also animate the either running animation or the idle animation. Okay, so we have this zombie run and this idle animation in our animator. And we saw that we can just trigger this is running boolean for one of the two things to happen. So either to go to the idle if it's not running, and to go to the run animation if is running is true. So in order to modify this based on certain behavior, we can get the speed of our enemy from the nav mesh agent. So we can just check if the velocity of our nav mesh agent has reached a certain point, and if it is bigger than a certain value, we can just go ahead and set the boolean to is running true. So let's check out how this actually works. So we can check here if the get nav mesh or get component nav mesh agent dot velocity. So here, access the current velocity of the nav mesh agent component, which will basically just give us the speed here, right? Dot magnitude. So this returns the length of the vector, which just shows us how fast the enemy is. And if that is greater than 1, we can just go ahead and say, okay, this guy is running. So let's start the running animation. So this value is just one value saying, okay, well, if the speed reaches a certain value, let's start running. You could also use a different value here, would be fine as well. But 1 I think is fine because the magnitude is going to be a float. Okay, so you could use a float here as well, which is fine. So now let's go ahead and create the animator object so that we can then access it. Okay, so here, public animator. I'm going to call this one enemy animator, like so. And now we just need to make sure that we set the enemy animator in our update method here to be set bool. And here we can now set is running to be true. Okay, so now we're setting this boolean here. This is running boolean. We're setting it to true if the enemy is at a certain speed. But if it's not, then we want to make sure that it's being set back to false. Okay, so here, if the speed doesn't reach a certain magnitude, then let's use false here, because then we know that the enemy should be using his idle animation and not be running. Okay, so now let's get back to our game. All right, and now let's see that in action. So therefore, our enemy will need an enemy animator. Okay, so let's give it an animator, and that is going to be the animator that we have inside of our root. Okay, so you can just drag the root here into the enemy animator, and root will have an animator. So here, root has this animator, and it will know to use this animator here. Okay, so now let's run our game. Let's see if the animation is going to be executed. You can see that the run animation starts running. And once we are close by, it's at the idle animation once again. Well, it's actually not. Let me see. Stops running. Then he's idle because he's not moving, right? We cannot see it very well. Only if we go to the scene view here, you can see the idle animation. Once I go far away, he starts running again. So now we have two problems. One of them is that I'm not super happy with the speed of the nav mesh agent. So in my opinion, something around 5.5 looked quite good because it fits roughly with the animation of the enemy. But now I also want to make sure that the running animation is going to maintain while his running is true. All right, and in order to fix the fact that our zombie running is not looped, you can activate, so go over to your animations under characters, assets, and tutorials EU assets, and the zombie run here, make sure that the loop time and loop pose are set to true. And now let's check it out once again. And you see now our zombie is going to run after us, and I think it looks quite good in terms of how fast he's running, and the animation fits quite well in my opinion. You can of course play around with this value just to see what looks better. You can really tell that this guy really wants us, huh? So he looks quite scary. He wants us, but we cannot shoot him. Well, he can't hurt us either, so it's all right. We're going to implement the hurting functionality as well as the shooting functionality a little later. But for now, let's have a quick break. Let's make sure that we save our scene and see you in the next video. All right, in this video, we are going to add a functionality that will allow us to notice whether we collided with the zombie or the zombie collided with the character. Because currently the zombie just runs into us and nothing happens, right? We don't have a debug log, nothing. So let's make sure that we are debugging once the zombie hits us. Therefore, I'm going to go over to the zombie and I'm going to give the zombie a capsule collider here, like so. And I'm going to put this capsule collider a little higher. So here you can see this is the capsule collider here. I'm going to set it up a little higher so the y coordinate will be centered at 2. The radius should be something around, let's say 1, okay, and the height will be 2.5. So something around that would be fine. We could use different values here, which would be fine either way. So 2 would probably be too much. 1 is, I think it's fine. All right. So if the zombie is at this point close to enough to our player, then we want something to be triggered. We will also need a rigid body for this, so let's make sure that we add a rigid body to our zombie. And I'm going to make sure that I constrain everything, okay? And I'm going to deactivate gravity as well here, because I don't need to, well, I don't want any of this to impact our enemy. So the rigid body should not be really impacted, but we're going to need it for what we're going to do next. So let's make sure that we open up the enemy manager, but before we do that, let me actually make sure that I apply all changes. Now in the enemy manager, we can get the on collision enter method, or use the on collision enter method, this one here, and we've used it many times before, so I assume that you know what it does. And here we're just going to check if the collision was with the player. So if collision game object is going to be the player, so if they're the same, so to speak, we know that the enemy has hit the player. So debug log, and here we can say something like player hit. So let's check this out. Let's get back to our game. And let's also, by the way, once we made the changes, let's make sure that we save our scene and let's run the game. Go over to the console as well. And now you will see player hit. Okay, so let me run away and boom, player hit. Okay, we're even being pushed up a little bit. And now there might be two questions that you have. So one thing is that we're getting pushed away at this point. So we're getting pushed away by the zombie, which is a thing. So you're getting pushed up a little bit, you see here. So which is something that you can avoid by changing the size of the colliders of your enemy as well as of you. We're going to take care of that a little later. But then another thing that you might wonder is why we are even using a rigid body, even though we're deactivating gravity and freezing all positions and all of that kind of stuff. Well, the thing is, we need that in order for us to be able to use this on collision enter method, which says is called when the collider slash rigid body has begun touching another rigid body slash collider. So while we're not actively using the rigid body as such, but we still need it for this on collision enter. Okay, so that's it for this video. In the next one, we're going to see how we can lose health when we are hit by the zombie enemy. So see you there. Welcome back. In this video, we are going to take care of player health. So we want to reduce the player health once the zombie hits the player. Okay, so the enemy knows how to hit the player, but we don't have a script for the player yet. So let's go ahead and create a new script. I'm going to call this one Player Manager. And this one, for now, it will have a very simple task. It will take care of health. Okay, nothing too complicated. So we can create this public float health, which we can modify. And we are going to set that, for example, to 100. And then we will need a method that will be called once the player is hit. So let's create a method, public void hit. And I don't mean the controller something hit, but our own method. And here I'm just going to say we can get a float amount of damage. Okay, so this will be the parameter that we're getting. And then we're just going to say reduce health by the amount of damage that you have. That's it. So this will basically say health minus damage will be the health. So we are reassigning health to whatever damage was subtracted. So let's say we're at 100 health and damage was 20 and we are hit. So this method is called once, then the health will be 80. So now in order to trigger this, we need to go back to our enemy manager. So let's save this script, the player manager script. And here, instead of just debugging a log player hit, we need to apply a certain damage. So let's first of all make this a variable that we can very easily adjust from Unity itself by creating this damage value here of, let's say, 20F, because this will be a float again, right? And then we can go ahead and now inside of this enemy hit thingy, so where we had this debug statement, we can just go ahead and call the method from the player manager component that was called hit. And we need to pass the damage to it. So this way we can now from the enemy manager call this player manager method called hit. Because it is public, we can access it. So we can just get the component player manager, which is the script, and we call it hit method. At this point, we can save our script and let's see if we can actually reduce the amount of health the player has once we're getting hit by the zombie. So you can see here now in our player movement, well, we need to assign this player manager script to the player as well. So let's add that to the first person player. And now let's go ahead and be attacked by the zombie. Okay, so the zombie was super fast. You see it attacked us, bomb, 80 health. And it attacks us once again, 40 health, 20 health. And well, now we're on top of him, so he can't hurt us. We go next to it, bam. Now we're at 0 health. So, well, of course, what we want to achieve is that the game restarts, at least for now, once we are at 0 health. So the player died and we need to replay. So let's create this first loop, this complete game loop, by reloading the scene on 0 health in the next video. Alright, now that our player can lose health, it's time to also reset the game. And how I'm going to implement it is going to be rather simple, and that is once the player health is at 0 or below that, we are just going to reset the game. So in our player manager, we have hit where we reduce the health, right? So here we can just check if the health is below equals 0. So if health below equals 0, then reload the game. So how can we reload the game? Well, first of all, we will need to have the scene manager here. So scene management, then we can use the scene manager class here and just load a scene. And I'm going to load the scene with index 0. So build index 0. That will pretty much be it. So let's save this script. Let's go back to Unity and also make sure that this scene that we have here, so the game scene, is actually part of our build. So over here in build settings, in my case, you see there is no scene. Well, there's one that is deleted, but I'm just going to add open scenes in there. And now you can see we have the scene/game scene, which has the index 0. So that's the build index that we're going to use here in our player manager script. So this one here, and it will load our scene. So let's see if we can get killed by the zombie here. So there we are. He pushes me away, and my health, let me see. And there we are. So now it reset the game, and we also have this graphical bug where the lighting isn't correct, but that's a Unity problem. Once you actually build the game, you won't have this problem. All right, so the reset actually works. Now let's fix this problem with the zombie pushing us up a little. So there are certain values that we can use that will help us with that. And that is if we change the capsule collider of our zombie here to the center being at 3.3, so it's at the head's height, so to speak. Then the radius being a little smaller, something like 0.6, and the height being 1. So it's basically just going to be the head that can destroy us. So only the head can eat us and hurt us, so to speak. Okay, so let's test this again and see if the enemy will still push us up if he reaches us. And you can see now the zombie reached us and he does not push us up anymore, which is good. All right, so that's it for this video. See you in the next one. Welcome back. In this video, we are going to use Raycasts in order to shoot, because what we want to do is we want to shoot from the camera position, because the first person player has the camera inside of the first person character here, the main camera. And what we want to do is we just want to shoot this blue line, or towards this blue line here. Okay, so this is the front of the camera. If we look at it from the top, it's a little easier to see. So we're shooting straight forward. That's how we are going to aim. Now you could of course say the weapon is slightly to the right. You could change the camera position a slight bit for that, but I think it's going to be precise enough for our case. So we're going to shoot straight this blue line. Wherever the camera is facing towards, that's where we're going to shoot towards. Okay, so let's go ahead and create a script that will take care of the shooting functionality. And I'm going to call this one Weapon Manager. Now let's check out this Weapon Manager here. And inside of the update method, I'm just going to check if the left mouse button was clicked. And in order to do that, I can use input get button down. And the button down that we're looking for is called Fire 1. Okay, so if you look at the axis in your project settings here, input manager, there is this Fire 1, which is your left mouse button. So it's either left control, that's also what you can press, or it's the mouse 0 button. Okay, so this will shoot. The name is Fire 1 with a capital F and the 1, Fire 1. So if we press the left mouse button, what do we want to do? Well, that's where we are going to shoot. So let's for now just use the debug log to test if this works. So let's say shoot. Let's save the script. Let's get back. Now at this point, let's make sure we assign this to the weapon. So this weapon manager script, because we have the upper chest, the right shoulder, the right arm. Is it here? Yes, the right hand owns the weapon. So it's pretty far down the hierarchy here, but that's where our weapon will be. So let's assign our weapon manager to the weapon. So here, let's add the weapon manager, and also the first person player, let's apply the changes, by the way, just to make sure that the weapon manager will be part of our first person player prefab. All right. So now let's run the game and see if pressing the mouse key will do something. And I will press a couple of times. Now let me go over to the console, and you see every time I'm pressing. All right, so that seems to work. So now instead of just debug logging here, let's actually do something useful, and let's shoot a ray. So we have used rays before, and I'm going to create an extra method for shooting here. Void shoot. So I'm going to call this one, and it will need the Raycast hit here. So Raycast hit is a struct, which is a structure used to get information back from a Raycast. Perfect. That's exactly what we want. So I'm going to call it hit, Okay, this raycast hit here. And we can now use this in order to store what we have hit with it. And therefore, we can use physics.raycast, and this will now cast a ray. So cast a ray from point origin in direction of length max distance against all colliders in the scene. Returns true if the ray intersects with a collider, otherwise false. So if we hit something, it will return whatever we hit. Okay, so there are multiple different overloads here. You can see plus 15 overloads, so in total 16 overloads. So let's just start with the first one. So first of all, we need to say where the origin is. Okay, so I'm going to use the origin vector 3 here. So I need to say where the starting point of my shot should be. Therefore, what I'm going to do is I'm going to create a new game object here, which I'm going to call player cam, which will be the player camera. Now, if you wanted to be super duper precise, you could say, okay, it's the weapon's central point where the bullet comes from. Okay, so that's up to you. I'm going to save the script now, and the code is complaining here. So let me quickly comment this out for now. So what I want to do is I want to use my main camera, as I stated, because the camera will always look towards where we are looking towards, and it will shoot from there. So that's why we're going to use the camera position here, as I stated earlier. So it will shoot from here, which is slightly below the actual weapon spot. Okay, it's super close, but it's not exactly there. It's totally fine still. All right, so now what we can do is we can use the player cam here in the weapon manager script. So let's make sure that we drag the camera in there, and it's this main camera. So you can just go ahead and search for main camera inside of the scene, this one here, and you can assign it there, or alternatively you could have dragged it in there. That's fine as well. So now we are going to use this player camera in our script to be the starting point, so the origin of our raycast. So here, let's use the player cam position, and therefore we need to get the transform property and then the position property. So this will be the origin where we cast the ray from. And by the way, now you can see an overload that is closer to what I wanted. So you see we have an origin, then we need a direction and then max distance or max distance. So let's use the direction, which will just be forward. I just want to shoot forward. So therefore we can just use transform.forward. Then I can define the max distance. For now, let's leave it out. And I also can get here the out raycast hit. Okay, so you see here we have this hit, and I would like to know what I have hit. Okay, so here I can just say out hit. What that will do is it will say whatever we hit will be stored inside of this hit variable. So that's what this out does for us. But then we can add a semicolon here. That would be fine for now. But then there are multiple other details that we can pass. So let's look at them. We can add the layer mask. We can add the max distance, for example, which is actually what I want to do here as well. So I'm just going to say that we can define the range up here, public. I think it's a float. Let me see what it says here. Let's look at the overload. You can always check here. So layer mask, float. Yeah, the max distance is a float, so that's good. So let's use this as range. And now we can define the range to, let's say, 100. Okay, so this will be the default range. That's how far we can shoot with our weapon. And then we can use this range here. So now this raycast will use this overload where we have the origin, the direction to where it will shoot. It will shoot forward. The origin will be the camera. The raycast hit will be our hit variable that we have here, and then we have the max distance that we set up as range. Now let's go ahead and check if this worked, because you see this raycast method returns a boolean. So what we can do is we can surround this with an if statement here, like so, and then we can just say what we want to do if it hits something, because it will return true if it hits something and false if it doesn't hit anything within the range in the direction or towards the direction of forward. So let's use debug log hit here this time. So we're going to say we hit something. All right, and now that we have that, we must of course run our shoot method in here. So let's make sure we execute our shoot method in the update method once we press the shoot button, so the left mouse button, so to speak. So let's save the script. Let's get back to Unity. Let's save the scene as well while we're at it. And once it's loaded, let's run the game and see if we can shoot something. So let's shoot the air first. You see we don't hit anything. Now let's shoot the zombie. And you see every time I shoot something, even if I shoot this wall here, you will see it will say hit. So now we of course will need to know what we have hit. Now we can try to shoot the zombie, but that won't help us much because, well, the zombie is invincible at this point. The only thing that can kill the zombie is the fact that we can pause the game anytime. All right, so that's it for this video. Now we know how to use the Raycast hit. In the next video, we're going to add a crosshair to our screen so that we know where we are shooting. Welcome back. In this video, we're going to take care of the knob and, well, basically the crosshair. Because if we play the game, we don't know where we are shooting. So we can have an estimate where we are shooting, but we never are sure or can be sure. So let's change that. Let's add a little UI element that will make it a lot easier for us. Therefore, let's go ahead and create a new UI element called image, or I'm just going to call this one crosshair. So this will be an image that we're using here. And what I want to make sure is that it is centered here, okay? I'm going to use a width of 10 and the height of 10 for this. And the source image that I want to use is going to be the knob. Okay, so you see we have a knob inside of the asset. So if you downloaded the assets from us, you will find this resource image there. And now we will have this knob in the center of our screen. You can see it there. If you want to make it a little bigger, you could change that from 10 to, let's say, 20, for example. That would be fine either way. So now you just have to define how big you want this knob to be. But now this knob is going to be pretty much in the center of our screen and it displays where we are shooting. So that really helps. You will have to make sure, however, that your crosshair is centered. So the anchor presets are center and middle. So here, this one in the middle. The position is 0, 0, which will be just in the middle of your screen. And the width is whatever you want to set it. And then of course the source image should be your knob, or if you have an actual cross, you could also use a cross there, however you prefer. And now I'd say let's take care of the actual health system of the enemy. So see you in the next video. Welcome back. In this video, we're going to take care of the health system of the zombies, and we're going to take care of shooting the zombies so that they can actually die and disappear once their health is at 0 or lower. And that is something that you could implement yourself actually, because you should be capable enough to implement that by this point. So you can learn a lot from, of course, our health manager of the player. So this player manager here, you will need to use the weapon manager and the enemy manager to get this done. So I wish you all the best if you want to try it for yourself. I hope you will try it actually. All right, so I hope you tried it, as I said, and now let's go ahead and take care of it. So inside of the enemy manager, we have the damage that the enemy can make. So the zombie can generate once biting us, so to speak. But we can also now add a health for the zombie as well, so for the enemy. So let's use 100 here, for example. And then we can go ahead and actually reduce this health using a hit method. So we can use the same kind of method that we used, well, not the same method, but we're going to build it the same way. So we're just going to use public void hit here, public, because we want to make sure that we can actually use it from other classes or from other scripts. And I want to pass how much damage a shot can do, because this will allow me to later on have different weapons that do different types of damage. So here, hit float damage. And now what should happen here is the health should deteriorate based on the damage that we are getting. So this method now, of course, needs to be called from our weapon manager script, because here that's where we are shooting, and currently we're just debug logging here. So we're not doing anything useful as of now. So instead of just doing this debug log here, let's actually check if the thing that we hit has an enemy manager assigned to it. Because if it does, then we know that we hit an enemy. So here, enemy manager, I'm going to call it enemy manager, like so. We'll get hit, transform, get component, and the component that we're getting is the enemy manager. Okay, as we have done before, right? So if the enemy was nearby with us, here we got the component of the player, and we then checked if the collision was with the player, and then we did the hit damage. Now this time it's very similar. We're getting the component and we're checking if enemy manager is not null. So only if it's not null, we want to do something with it, because then we know that we hit an enemy. So let's use the enemy manager to call its method hit, and let's give it some damage. Now of course we need to define how much damage our shots will do. So public float damage, let's say our damage is 25. So now every shot will do 25 damage. And now we can just go ahead and say hit with damage. Now this will allow us to hit the enemy, but it will not kill the enemy. So let's test this real quick. All right, so let's shoot the enemy a couple of times. Shoot, 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 shoot. And now let's actually check the scene and click on the zombie to see its health. It has 75 health. Okay, so it seems like I didn't shoot it enough yet. So let me click on the zombie and let's see if I can kill it. Okay, now its health is at 0. And well, actually my health was at... So either way, I killed the zombie, but it didn't die. That's what I want to say. So you see, I'm really bad at these games. So let's go ahead and actually take care of killing the enemy. And that's what we can do in the enemy manager, because once we hit the enemy, we can check if the health of the enemy is below 0. So here, if health is less than equal 0, we know that we need to destroy this game object. Now, either you can use this here or game object. Either way should be fine. This will destroy the enemy manager holding game object, which means the zombie. Because the zombie holds this enemy manager, and this will destroy the zombie. So here, destroy enemy / zombie. Okay, now let's check it out. Let's see if I can actually kill the zombie. And I feel like, by the way, let me look at the zombie here. I feel like the zombie isn't big enough. I need to make the zombie bigger, maybe. So here, this part here. Let me make sure that this part here, this mesh agent, is a little taller. 3.5 maybe, or even 3.9, something like this. Okay, now it will be a little bigger. All right, so let's play the game. Let's see if I can kill the zombie before it kills me. Okay, yeah, I got him. Got him! Okay, I needed quite some shots. Even headshots didn't help. But yeah, I killed the enemy. So the zombie was gone. The zombie was destroyed, which is great. So now we know how we can actually destroy enemies. And I'd say in the next video, we're going to implement the animation, because currently we are shooting and we don't really see anything. So of course we need to have a little animation of the actual shot, then maybe even a visual representation like I don't know, like a fire splash or something like that, as well as what we're going to do is we're going to move the weapon just a little bit, so create a little recoil effect which will give us the feeling or the sense of shooting. Quick pause. The video that you're watching right now is just a fraction of the entire FPS course. In the course, you're not only learning how to build a first-person shooter, but also make it a multiplayer game. So you're going to learn a bunch more things than in this YouTube video. It's a 7.5-hour course, and you can not only get the course, but you can currently also get the book with a 50% discount. Definitely check out the link in the description below to improve upon what you're building in this video and become a real multiplayer game developer. So let's take care of that. Therefore, I'm gonna go over to my animations here inside of characters. So characters, animations, let's create a new animator controller. This one here, animator controller. Let's call it FPS animator, like so. Let's open it up, and now let's drag in FPS idle as well as firing. Okay, so these will be the two animations. As you see, we have prepared those two for you already. And what we will need is a new parameter here, a boolean. I'm going to call this one is shooting. Okay, this boolean here. And now what we can do is we can make a transition from idle to firing. And this transition should only run if is shooting is true. And now from firing to idle, and this transition should happen if is shooting is set to false. Okay, so these are going to be the two animations that we have here. Now we also want to make sure that they don't have an exit time. Okay, so let's do that for both of them. And also here, if you open up the settings, I would like to deactivate this fixed duration for both of them. Okay, what that will do is it will make sure that we can shoot and shoot again, like halfway. So the animation will stop halfway and restart the moving forward, so to speak, if we are shooting straight while the recoil is still running. So it will not go all the way back before the recoil will start once again. It will basically restart halfway, so to speak. And that's exactly what I want in terms of this behavior in that particular case. So now we need to toggle this is shooting. For now, let's make sure that we test it like so here. So we have the two screens. Let's see. Actually, we need to assign the script first. So here, the animator of our FPS character. Let's add this FPS animator to him, like so. So make sure, click on the FPS character. You see the FPS character has an animator that didn't have a controller as of now, but now it does have one. So let's run it. And let's see if we can shoot. You see FPS idle is being executed all the time. So now let me shoot by triggering this is shooting, and you can see this is the effect that I was talking about. Okay, so activating, deactivating, and if I do it very quickly, you can see now we have this recoil effect of my weapon. All right, so that's it for this video. Now we have added the recoiling effect, at least the theory behind it. Now let's make sure that this will be triggered once we are shooting. So see you in the next video. Welcome back. Now let's actually animate once we are shooting and make sure that we are setting the boolean correctly. So we have this boolean is shooting. We can activate it and deactivate it. So we want to activate it once we are shooting, but just the frame later, we want to make sure that we're not shooting anymore. So at least this boolean is deactivated. So let's have a look at how this is going to pan out. So the first thing that we will need to do is we need to go to our weapon manager. And that will be under our scripts here, weapon manager, this one here. So this is where we are shooting, right? So what we can now do is in the update method, we get the button down fire. So we know we shot, okay? So now what we need to do here is we need to start the animation. So let's create a variable animator that will be the player animator. Even though it's not really an animation for the player, it's actually an animation for the weapon, but it's more or less the same thing here, right? So we get the player animator here, and we will need to assign it, of course, to our weapon manager script in Unity. So now what we can check in the update method, not only if we get the button down, but also if we are shooting. So we can just say player animator get bool. So we can check, is the bool is shooting set to true. And if that's the case, then go ahead and set that boolean to false again. So here is shooting. Let's set that to false like so. And then at this point, do the actual shooting once we get the input detected. Now inside of shoot itself, we also need to make sure that we are actually setting the shooting to true at one point, because otherwise it will never be set to shoot. So player animator, set bool, and here we're going to say is shooting should be set to true. So let's look at this by frame steps. So here at the beginning, is shooting is set to false. Then input is detected and the shoot method is called. And then at the bottom, you see in the shoot method, the boolean is shooting is set to true. That's in the first frame. Well, in the moment that we're shooting. Then in the following frame, the is shooting is now true. So we're setting it back to false. Then input is detected and we're shooting again, or we're setting the shoot method again, and the shoot method will set our is shooting to true again. Okay, so that's what is happening in our case right now, even though this might not be frame 1 and frame 2 in the sense of exactly after another, because we don't shoot 60 times per second, for example. If we have 60 frames, I don't think that you can shoot as quickly. Some people might be able to do that, but most of us can't. So that is how it's going to work. Okay, so now let's make sure that we are saving the script, by the way. And once we have saved the script, we can go back and we can now make sure that our weapon manager and our FPS character / weapon here owns the weapon manager. It now needs a player animator. And the player animator is going to be the FPS character, or at least the FPS character owns it, because here, that's where the animator comes from, right? So this animator that is owned by the FPS character holds the controller that is our FPS animator controller, which then holds the animations and the order in which they are being executed. So it will now set this is shooting to true and false based on our behavior. So based on whether we shoot or not. So let's see if this is actually going to work now. So let's shoot, and you see the animation works. So even if I'm very fast here, you see it doesn't finish the animation entirely, and it works well here. So let's try to shoot this little bastard, and there we are. Dead. Zombie dead. Okay, cool. So that's it for this video. See you in the next one. So let's look at spawners and how spawning works. So similar to titles like Call of Duty and Gears of War, wave-based spawner systems are, in short, a mechanism to spawn enemies in waves based on separate rounds, usually upping the difficulty with each round. So in our case, we want enemies to spawn from set spawn points with an amount depending on the current round we are in, then using their pathfinding system to find their way to the player. So they should all run towards us. This gives us the possibility to modify each round how it feels, what enemies we fight and their stats, even things like movement speed, special abilities, and a long list of other features that you want to have. So let's get implementing. Therefore, let's go back to Unity. And we mustn't forget one thing, and that is our navigation here. Okay, so you might recall that we had these blue areas where our enemies can run on. They cannot run on areas that aren't blue. Okay, so that's something we need to take into consideration. So we even made sure to leave space for enemies to spawn outside the map boundaries, just so we don't see them appear out of nowhere. So if you look at the map here, you can see that here, for example, is an area where the enemies could spawn from. And in front of it, we have a invisible wall. So here, you cannot really see it very well, but yeah, there is an invisible wall. So we cannot walk through it, but zombies can now come from, for example, this spot here and then walk over here. We cannot see them when they are spawning, which is always good. So that's something you should try to achieve. So let's go ahead and create some spawners. Therefore, I'm going to go ahead and create a new empty game object, which I'm going to call spawners. Now let me make sure that in the inspector, the spawners are reset. So it's set to 0, 0, 0. It's always good if your parent objects are repositioned at 0, 0, 0. And now let's create individual spawners. So now let's create an empty game object in here. I'm going to call this one spawner. We can even go as far as to say spawner and then 0 in brackets. So this will be our first spawner, and then we will duplicate this one to create more spawners. I'm going to duplicate this a couple of times using the Control and D key shortcut. And then the positions that I would recommend that you use are for spawner 0, 15.75 for the X position, 0 for the Y position, and minus 13.31. And by the way, actually you can just copy them from here. So just pause the video and set up your spawners with these values if you want to use the same spawner positions as we have used. Okay, so here, these are the ones that I'm going to assign now. What you also want to do is, or I would recommend you do, is you add a little gizmo here. So I'm just going to add this little diamond gizmo. Currently they're all at 0, 0, 0 for me, but this one spawner here is going to be over here. So I want to be able to see it in my scene, and it seems like the gizmo is a little small, so you can also use this one here to make it a little more visible. So this will be spawner 0, and then we have the individual spawners here, 1, 2, 3, 4, and so forth. Once you're done with the positions that I shared with you just a bit ago, you should have spawners at these locations as you see here. So these are the 5 locations. They're just behind trees and behind these walls that we cannot penetrate as the player. And that's where we want them to spawn. This in the middle here is going to be the player and not the spawners, right? So these slightly transparent squares here, that's where the spawner should be. All right, with that, I'd say let's implement the spawner code that it will actually spawn those monsters for us. So see you in the next video. Welcome back. In this video, we are going to take care of spawning enemies, and therefore I'm going to create a new script. I'm going to call the script Game Manager because, well, it's going to be the game manager that is going to take care of spawning, because the game manager should also take care of which round we're at and how many enemies we have currently and stuff like that. So you see here, Game Manager, you get this tool wheel as we have seen before whenever we created the game manager. So let's go ahead and create a game manager object here as well straight away. And let's drag this, well, let's first of all reset this position and let's drag the game manager in there. Okay, so now we will have a game manager in our game. That's always good. And now we can go ahead and take care of the script. So the first thing that I would like to know is how many enemies do I have in my game that are live, and then which round am I at. So I'm going to create these 2 integers that we can then adjust and also see in Unity straight away. Of course, you could have also made it serializable here for it to be available and made it private, but I think this will be fine. So now inside of the update method, what I'm going to check is if we have enemies that are alive or not. And if we don't have any enemies alive, which means we are at 0, we're going to increase the round. So at the beginning, we're at round 0. At the beginning, we're at 0 enemies that are alive. So that means in the first iteration of this update method, this will be executed and the round will be increased. So what do we want to do once we increase the round? Well, we want to call the next wave. So let's create a method that will take care of calling the next wave. And I'm going to call this method next wave, and we will need to pass the round to it. So public void next wave with the round. Now, of course, we want to spawn the enemies at random locations. So let's go ahead and make sure that we get the spawn points in our game manager script. So this will be an array of game objects. I'm going to call this one spawn points. So now what I want to do is inside of my next wave, I want to randomly spawn an enemy. Well, an enemy at a random location out of those spawn points that we have. And we've seen how to do that before. So I'm just going to paste the code in here where I'm getting the spawn points length, and I take one of the spawn points randomly between 0 and the length of the spawn points using random.range. So this will now be the spawn point at which I want to generate a new enemy. So what kind of enemy do I want to create? Well, it's always the same, right? We need to know which game object we want to use. And I'm going to use the enemy prefab because that's the point where I want to generate the enemy. Now that we have the location and we have the enemy that we want to spawn, let's go ahead and actually spawn the enemy. And therefore we can go ahead and use the instantiate method. So this will now instantiate an enemy prefab at the spawn point position with the quaternion identity, which means with no rotation. So now, once we've done that, a new enemy will be created. So we need to make sure that we increase the enemies that are alive with the next wave here. But now that would only create one enemy. But this next wave should create as many enemies as we have rounds. At least that's the plan that I have here. So we need to run a for loop here, which will start at 0, and that will check the length of rounds that we have. So how many rounds did we have so far, and increment this by 1. So this should happen for the amount of rounds we have played so far. So the next wave, let's say at the beginning, is at round 1. So we're going to spawn 1 enemy. In the second round, we'll have 2 enemies, and so forth. So now let's just make sure that we're actually calling our next wave here with the round that we're at. Otherwise, nothing would happen, right? So we prepared all of this beautiful code, but it's never going to be called if we don't call it here. Okay, so every time that the enemies alive are at 0, the round should be increased. So the round should be incremented, and then we call the next wave, which will have more enemies. Okay, so let's go back to Unity and let's make sure that our game manager gets all the details that it needs. Because if we look at it, it needs to know the spawn points and it needs to know the enemy prefab. So what I'm going to do is I'm going to go over to my zombies. Let me check my zombie here. Let's apply all changes, really making sure that the zombie is going to be correct. So let's delete this zombie because we have it as prefab. It's really important. Or actually what we can do is we can even go to our assets. We could even create a new prefab here. So prefabs folder. And I'm going to drag the zombie in here because I want to use the original prefab here as the zombie in my prefabs folder. Okay, and now inside of my game manager, let me drag this zombie in there as the enemy prefab. And now let's make sure that we have our 5 spawn points. So what I'm going to do is I'm going to drag the spawners here. Well, I can also do it writing spawner here. So spawner 1, spawner 2, spawner 3, and then finally spawner 4. So now we have all of the spawner locations, and now our enemies can spawn randomly. And now, by the way, let me get rid of this default zombie that we have here. Let me save the scene and let's start the game. So let's see if we can actually find an enemy in our game. There he is. Whoa, damn, this dude is running after me. So let me kill it, or try to kill it before it kills me. And as you have seen before, I really suck at this game, and I'm not sure whether our settings are correct for the size of the enemy, so we will need to change that. So now we have a little problem. So I killed the enemy, but it's never actually noticing, well, our game is never noticing that we don't have any enemies in the game anymore, because this enemies alive here is never set to 0 once we shoot an enemy. So let's fix that in the next video, because we need to make sure that this is going to be triggered in order to trigger the next round. So see you there. Welcome back. Let's actually take care of our enemies, so our zombies, calling that they are dying. So inside of the enemy manager, we now need to take care of that. So let's get an instance of the game manager in here. So like this, game manager, which I'm going to call game manager, like so. And we can now get the game manager by dragging it in. That will be fine. And now, once the enemy is being hit and destroyed, we need to make sure that we are reducing the amount of enemies that we have. So here we can go ahead and say game manager dot enemies alive is going to be decremented. So we're reducing the amount of enemies that are alive. Because if you recall, in the game manager, we had this enemies alive variable that will be increased for every single enemy that is instantiated here. So now what we're doing is, once we are destroying an enemy, we are reducing the amount of enemies that the game manager knows about. This will make sure that the game manager is always up to date with the enemies that we have spawned. So now what we can do is we can of course drag the game manager in Unity. That's one way. But now I'm going to show you a neat little trick, and that will be here. I'm going to use this instantiate in order to create a new game object, because you know this instantiate returns a game object. Okay, so what we can do is we can say game object, and let's say we call this one enemy spawned, or spawned enemy, or whatever you want to call it. And now we can use this enemy spawned in order to get its component, so get its enemy manager script, like so, and set the game manager to be this current component. So get component of the current game object that is called game manager. So this is a neat little trick where we don't need to drag the game manager in manually, but it will be done via code. Because as you might recall, this enemy manager here needs a game manager. So either we will drag it in manually, or we just say, okay, this game manager script is going to be the game manager that we want to assign to you. And that's basically it. So now let's get back to our game and let's see if we have some enemies that are spawning that we can kill, that then spawn the next round and stuff like that. So let me see, where are the enemies? Oh, there he is. So let me shoot it. Actually, let me change the amount of damage I do, because I feel like I'm way too bad at this. So where was it? I believe it was in the weapon itself. So here, let's go into root, chest, right arm, right forearm, right hand, weapon. So here, the weapon damage, let's make it boom, 100. So once I hit once correctly, the enemy will die. So I'm making it easy for myself, at least for testing purposes. So let's see, there is the enemy. Let me shoot it once, and it seems like something is definitely not correct with me shooting it. So now there are two enemies coming. Let me shoot those two. Okay, done. So let's see where the three enemies are coming from. You see they come from different corners of the map. Holy moly, it's getting scary already in round 3. What the frick? So let me... my game is not working correct yet. So I need to definitely make sure that the animation is set correct, or the shooting is set correctly. Okay, that seems to work. Headshots seem to work. Okay, that's good. So there's the next enemy, headshot. I believe I need to be too close to them, so I need to change the range that I can shoot. Boom, boom, boom. Headshots work flawlessly. All right, that's good. Good to know. Actually, the distance is fine. Whoa, 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 whoa. Easy, easy, easy. Okay, so now you've watched me play a shooter game for a couple of minutes. I think it's enough. So you see, it was enough. I was killed. So I made it up to round, I believe, 7 or 6 or so. And I don't even know which round I was at. And that is something that we need to fix. And how can we fix that? Well, we can fix that by adding a beautiful UI. Well, it doesn't have to be beautiful, and it won't be, but it will be a UI. So it will be a UI that shows us in which round we are, how much health we have, how much health the enemies have, all this kind of stuff, step by step. So see you in the next video, where we're going to get started with the rounds UI. So see you there. Welcome back. In this video, I would like to implement the functionality where we can then see at the top left corner in which round we are. So let's say we are at round 0, then it should say round 0. Then once round 1 starts, it should display round 1. So that's something that you can actually implement yourself already. You will of course need to use the game manager's round number here in order to then display it over here. So good luck achieving that. Okay, I hope you achieved it, and if you did, then you can move over to the next video. So what I'm going to make sure of is that I'm using full HD, because then we are going to use the same numbers. Okay, so you can just set up full HD. I assume most of you have a full HD screen, and then right click here and create a new text. Then you will get this new text here, and I'm going to call this one round text. So let's rename it round text, like so. Now let's make sure that this round text will be at the top left corner, because now it says new text here in the middle I would like it to be at the top left corner. So I'm going to select this anchor preset and let me set the position to 0, 0, and it will now be at the top left corner. So now from there we can move it a little bit. So let's go over to the round text and you will find that it is currently at the top left corner, just outside of our screen. So this white line is our screen, and let's move it a little bit like so over here, roughly like that. So I believe values that are, let's say, around 90 or 100, something like that, 90 minus 30 seem to be good for us. So what I'm going to define the height for is going to be 50. The width of 160 should be fine. Let's change the text so it's going to say something like round 0. Then we can change the font size to maybe 40 or so. Let's see how this is going to look like. 40, well, maybe even more. So let's do 60. Then I assume we have to change the height as well. Let's try 70 and the width of 250. So this will be a little bigger now. Then the position also has to change. So here, let's do 150. Well, it really depends on how you want to do it. So something around that space should be fine. Now you can align it towards the center, but then you will run into the issue where the number would then float over at one point. So let's make sure we align it to the left, and we can overflow it in both directions. Now also let's change the color to white so it will be more obvious. Now you could of course go ahead and create some cool color and some specific background for it and use a different font here, but for our purposes this will be good enough. Now in our game manager, in the script, we can now use this round text. So let's go ahead and set up our script for it to work. So whenever we want to use text, we need to make sure that we are implementing the UI namespace, and then we can go ahead and just create the text object here. I'm going to call this one round number. And now we can go ahead and set this round number, and I'd say we're going to set it every single time that we increment the round. So here we are incrementing the round, so let's change the round number to be whatever the round to string is going to be. So this will just display the number for us. So you could either say round plus round to string. I think that would be the easiest way, and even round column, something like that. Then the text would display round and then whatever round we're currently at as a string, and would store it inside of our round number. Okay, so let's save the script. Let's get back to Unity. And now our game manager should allow us to drag in the round text. So let's go over here and we can see here round number text. Okay, so let's drag in the round text here and let's see how this is going to pan out. So let's shoot a zombie. Let's see where it comes from. I'm a little scared. There it is. So, oh, I wasn't shooting. Okay, I was outside of the game. Headshot, there we are. So it says round 2 now at the top. Headshot, another headshot. Let's see if I get that one. Boom, round 3. All right, so now it displays the round number beautifully. And that is pretty much it. Okay, that's it for this video. I hope you achieved this by yourself. If you didn't, no worries. Now you see how it's done. So now a little challenge for you for the next video. Create the health UI. So just display the health in a similar way as you do the round, and I mean the player health here to be specific. So see you in the next video where we're going to do that together. Welcome back. So I hope you followed the challenge and tried to do the same thing with the player health. So the first person player health, and you displayed it somewhere. I will display it at the bottom right for now. So let's go ahead and just implement it. So therefore I'm going to require another text. So let me just go ahead and create a new UI text. I'm going to call this one health text. And now let's change its settings up a little bit. So I want it to be at the bottom right, as I stated. So let's set it to 0, 0. You can see it's there. Well, you can probably not see it, but it's there. It's super small. So let's change the height up a little bit. Let's change the Y position. Let's see if we put it a little higher and the X position a little further to the left. Then we should be good to go. 200. Let's make it a 300 width, like so. So a position of, let's say, 100 minus 180, or maybe 150, something like that. Really depends on what you prefer. I'm going to put it at around 50 for the Y position. Let's make sure that the text will be in white, like so. Now it's visible. Let's put it towards the right hand side. Then we would actually want it to be just still a little further to the left. Something like maybe even 200, minus 200 should be good. So let's display 0 health or 100 health. Okay, that seems good. Let's do a gazillion health. All right, then it puts it into another line because of our limited width. But I think this should not be a problem with our game because I don't want to display more than 100 health. So now you can of course play around with the font size if you want it to be bigger, such as for example 60 for the font size. You also have to change the height, or you have to make sure that you overflow here. Okay, now we will overflow with our health in both directions. Now let's just make sure that our health text will actually be used in a script that will display the health. So the health is saved in the player manager here. You can see it, health is set to 100. So let's make sure to use this health here. Therefore, we will need to make sure that we are using UI here. So this namespace, and then we can get the health of the player. So here, public text, health text, and let's use it like this. And now we can use this health text inside of the hit method, because that's where we are setting the health each time. So here health text.text should be health to string. But as I want to have the text health before it as well, it will be the keyword health plus the value, because the health is a float and we're just converting it into a string, and we are going to display it in here. All right, that should be it. Let's save this script. Let's go back to Unity, and then let's assign this health text to our first person player manager script here. So let's drag over health text and let's run the game and see if zombies can now reduce our health at the bottom right hand corner. So let them attack us, and boom, he attacked us. And actually, as it seems, I am using it the other way around. So I started with health first, so we can also do it this way around. So number plus empty space health, no empty space after. All right, you can of course also use capital letters here, health. This will be a little more visible, or maybe even something like HP, something like that. All right, so that's it for this video. Let's not forget to save our script here, and I hope you were successful with this challenge. See you in the next one, where we're going to take care of the end screen. See you there. All right, so now let's take care of an end screen. And what I would like to do is I would like to add a layer here, which will be slightly transparent, but at the same time will be red, and then we'll have a bit of the text here saying something like game over, round survived, then the amount of rounds, and then a play again button. Okay, so let's go ahead and implement that. Therefore, I'm going to create a new UI element, and that will be a panel here, like so. And you see now it already has this transparent look, and I'm going to make it something like this red here where it looks like, okay, well, seems like we're dead. So this will be our end screen. Let me actually put it. So what we could do is either we could make this itself the end screen. So I'm just going to do that, end screen, something like that. And now inside of it, I want to have a text. So here UI text, and let's call this one game over. So this text will be in the middle. I want it to be white text. Okay, it will not be exactly in the middle, but it should say something like game over. And of course it has to be significantly larger. Let's make it centered and overflow towards all directions so we can actually see it. So probably 80 or even more would be better. So maybe something like 100, but then make it bold. Okay, that looks a little better. Let's reposition it. So I'm going to position it further towards the top. Something like, let's say 300 should be fine. Here you can play around with the width and height if you want to. We're using overflow, so it shouldn't be that much of an issue, but still you can of course set it up to be, let's say 120 for the height, 800 for the width, something like that. Now let's take care of our second text, and I'm going to just duplicate game over. I'm going to rename this rounds survived. And this text will be saying rounds survived. And I'm going to make it smaller, maybe something like 60. I think this should look a little better. Let's position it at 100. Let's see if that's going to be fine. Maybe 150. That looks a little better. Maybe also not bold. Let's see how that's going to look like. Well, maybe we want to leave it bold, but let's use 50 here. Okay, so this will say rounds survived. And now let's duplicate rounds survived, and let's call this one rounds survived num. So this will be the number displaying how many rounds we survived. I'm going to set that to 0 by default, like so. And then let me position it a little lower as well. So maybe not 0, maybe something like, I don't know, 70. I think this should be fine. Maybe we also want to change the font size here so that it will be more obvious. So 80 or even 90, so it's a little bigger. Okay, so that will be our rounds survived text and the number. All right, and then I would like to have a button here as well. So let's create a new button. And that button should be a little lower. So let me first of all change the text of the button and the name of it as well. So replay button is going to be the name of it. I'm going to change the text to something like play again. Let's also change the size of this button. So currently it's at 160/30. So let's use something like 460 maybe. Then let's reposition it. So I'm going to use a Y position of -120, something like that. And the text should also, of course, be bigger now. So let's use 30 here, maybe 40 even. Yeah, 40 seems fine. You could make this button even significantly larger if you felt like it. I'm going to make the text bold to make sure that it's going to be well visible. Okay. Maybe even say something like play again, like that, with 45 as a font size. So this should be good. Okay, now we have the UI, game over, round survived, amount of rounds, and then play again. Now, of course, none of these things do anything, and that's what we're going to change in the next video. So see you there. Welcome back. Let's take care of our game over screen. We're not going to take care of the button yet, but we're going to display the rounds that we survived, as well as, well, make sure that we display the end screen, because by default, I want it to be disabled, because only once we're dead, the end screen should be displayed. So let's go over to our game manager, because our game manager takes care of the next wave, and it should also take care of when the game ends. So let's create a new method. and let's call it end game, like so. And what do we want to do when we end the game? Well, we want to display the end screen. Okay, so let's make sure that we can find the end screen. So I'm going to create a game object that will be my end screen. Okay, now I can go ahead and deactivate the end screen and activate the end screen from this script. So let's set it to active true so that it's going to be visible. And now in our player manager, we will need the game manager. So let's go over to our player manager. Up here, let's add the game manager because we want to call the game manager's method now. So let's create a game manager object here. We're going to need to assign that game manager, of course. And now instead of saying load scene 0 here, I'm going to call the game manager and its end game method. Because we used this method here, this load scene 0 at this point, because it was convenient, right? But this is something that you should usually outsource to your game manager. The game manager should control the game state. Okay, so we can get rid of the methods that we're not using here in the player manager, by the way. So it will be a pretty short script. So back in the game manager, we can now actually take care of displaying the end screen. As well as, I'd say, let's pause the time. So time.timescale, let's set that to 0. And then let's also make sure that our cursor is usable again. So cursor lock state, cursor lock mode none, which means that we will easily be able to move out of the game in Unity. Okay, so this will allow us to move out of the game in Unity. And then we will need to know how many rounds we survived. So let's go ahead and create another entry for the text here. So public text, rounds survived, like so. And now we can use this round survived in order to display it in our end game here. So we can go ahead and use rounds survived dot text to be the round to string. So however many rounds we have survived, that is what is going to be displayed now. Now at this point we cannot reset the game yet, which is fine. Well, we got rid of this method that would do it, and that was in the player manager, right? So we said end game. So now we're going to add the button later on. We're going to add this game over replay button here, the functionality of replaying or resetting the game, because currently we don't have a way to do it. All right, so now back in Unity, let's take care of our game manager actually knowing what is the end screen. So let's drag that in there, and let's drag in the rounds survived num to be the rounds survived here. And now let's run the game, and let's see if we can display the amount of rounds that we survived. So I killed one monster. Now we are going to be in round 2. Let them kill me. Okay, there they are. So now eat me. And it seems like I still have a null pointer reference. Let me check. The game manager in the player. Okay, that's good. It's always good to test this. So there we are, the game manager. Let's make sure the player manager knows about the game manager as well. And now let's start the game once again. Let's kill one zombie. Where is it? There it is. Okay, I killed one. Where's the other ones? Okay, so now please kill me. And boom. So there we are, round survived 2. And now what we want to do is we want to be able to play again. So the game is frozen, as you see, nothing is moving, and we can now potentially play again, even though you saw we had the monster in front of our face and I could still shoot it, which is fine, not really that much of an issue. But let's save the script for now, and let's save the scene for now, and see you in the next video where we're going to take care of the replay button. Welcome back. In this video we're going to take care of the replay button or restart button, however you want to call it. So what we want to do is in our game manager we want to make sure that we have an option to reset the game. And to reset the game, we're just going to load our scene 0 once again. So let's create a new method here, public void restart. And this method will do nothing too fancy. It will just use the scene manager and will load the scene 0. So now this will of course only work if we have the right namespace. So let's make sure we have scene management in our namespaces here. So using Unity scene management, which will add this line here at the top. Okay, so now we have this method restart, which will just restart the game. Now there's something that we mustn't forget, because if we forget that, our game won't work correctly. So we also need to make sure that we set back the time scale, because if you don't do that, then the game will be frozen and you cannot move, you cannot play. Because in end game we are setting the time scale to 0 and it stays there even if we reset the scene. So we need to make sure that we set the time scale back to 1 and then we can move on. Alright, so let's save this, and now let's make sure that our replay button knows how to use it. Therefore, let's click on the replay button on the right hand side. Let's add this on click, and now we can go ahead and use the game manager here. Let's use the game manager, the scene game object, and then under functions you will find game manager, which is the actual script, and here we can use the restart button or the restart thingy. Okay, so now this will call the restart method. Let's save this scene and let's have a look if we can actually reset the game. So let me shoot some zombies, or let me actually die from zombies. Don't want to shoot any of them. And there we are. Now let's press play again, and we can see we are back in the game. Even though we get this weird Unity bug where the lighting is all bugged up. So let's see if that works again. Okay, play again, and it works flawlessly. Quick pause. The video that you're watching right now is just a fraction of the entire FPS course. In the course, you're not only learning how to build a first-person shooter, but also make it a multiplayer game. So you're going to learn a bunch more things than in this YouTube video. It's a 7.5-hour course, and you can not only get the course, but you can currently also get the book with a 50% discount. Definitely check out the link in the description below to improve upon what you're building in this video and become a real multiplayer game developer. We're going to take care of the main menu. Therefore, I'm going to go over to my scenes, and as you see, I have a scene here, which is the game scene. But now let's go ahead and create a new scene, which I'm going to call main menu scene, or just main menu is fine as well. So inside of my main menu scene, I want to have a panel here, and I'm going to call this one main menu. Let's change the background color of it to black and make it less transparent. So I'm going to make it 0 transparency. So 255 for the A value. And now on top of that main menu, I want to add my text. So I'm going to add a little text that's going to say something like incredible game. So let's go ahead and call this one incredible FPS zombie game. Okay, and now let's make this significantly larger, something like 80. Let's make sure that it overflows in both directions, that it's centered, that it's a little higher, and I'm going to use something like 300. It's maybe too much, 200. Okay. Let's also change the color to white. Okay, so it's going to say something like incredible FPS zombie game. That's fine. Now we can go ahead and create buttons. So UI button here, and I'm going to call this one start, like so. And let's also change the size of the button. Let's say we take a width of 400, a height of 100, or maybe just 80. 80 should be fine. Now we can position it as 0, 0, 0. That should be fine. Let's change the text a little as well. So let's say play here. Let's change the font size to 60. 60 looks good. So now it's going to say play. Let's make it bold also. Yep, that should be fine. Let's duplicate the start button. Let's change this text to exit, or the name of it to exit. It should also say exit instead. Now, of course, we need to position it somewhere else. So, and I don't mean the text, I mean the exit itself. So here, let's use 150, something around that, maybe 180. That looks good. Okay, so now we have the start and the exit button, and we have the title of our game, Incredible FPS Zombie Game. Let's make sure that those buttons are also going to work. Therefore, in the scripts folder, I'm going to create a new script. And I'm going to call this one Main Menu Manager. Okay, so let's check out the Main Menu Manager. So what is it that we want to do? Well, we want to give those two buttons a functionality. So we're just going to use a new method that I'm going to call Start Game, which should only do one thing, and that is use the Scene Manager. So let's go ahead and make sure that we can use the Scene Manager. I hope you recall how to do that. We needed to add the scene management here. And now we can use the Scene Manager to load the scene. I'm going to load the scene. I'm going to say load scene 1. So why is that? Well, let's look at the build settings. So here, if we go to build settings, I want to add the open scene as well. So now, unfortunately, the main menu will be scene 1 and the game was scene 0. So I'm going to change that now. So I'm dragging main menu to 0, which means that it will now be the entry point of our game, and the game scene will be now at scene 1. Okay, so let's make sure that that is stored like that. And now in our Main Menu Manager, we can just use the build index 1. Now you could have also just called the name of the scene, and the scene name was, I believe, just game. So you could have also just said game here, or game, I think it was written like that. But using the indexes is a safe way, because let's say you change the name of the scene later on, then this code wouldn't work anymore. Well, in this case it will, but if you were using the string, it wouldn't work anymore. And now we need to have another method, which is going to be public because we want to use it inside of Unity. Public void exit game. And what this method will do is it will just use the application.quit method. So this method will simply close our game. So access the application runtime data and then quits the player application. So this will shut down the game. So close the game or quit the game. Maybe that's more obvious here based on the quit method. Okay, so let's save this. We have made sure that the code is ready, but now we just need to make sure that this Main Menu Manager is going to be inside of the game. So let's create an empty game object. I'm going to call this one Main Menu Manager. And now let's go over to our start button and let's make sure that we add the Main Menu Manager here. And now I would like to use its methods, but of course it doesn't have them yet. That's because we didn't assign any. So let's reset the Main Menu Manager and let's drag the script in there. Now the start button has the Main Menu Manager still in there, but now we can access the Main Menu Manager from here and we can access the start game method. That's for our start button. Now let's do the same thing for the exit button. You can pause the video and try it for yourself, of course. So add a new entry. Make sure that the Main Menu Manager is dragged in there. Select the Main Menu Manager here and select exit game. All right, and that should do the trick. Let's see if we can exit the game first. And unfortunately, we cannot, at least not from Unity itself. Let's check if this button is working. Therefore, I'm just going to add a debug log statement here. Quitting game. Like so. Let's save the script. And let's run it once again, once it's loaded. And let me press the exit key. And you see it says quitting game. And at this point, we cannot really test it properly, right? But we can test the play button. So let's test it. Let's see if we can get over to the other scene. There we are. So we're moving from one scene to another, which is great. So there's the zombie. Let's kill it and now let them kill us. So here, let's reduce our health. And now let's click on play again. And you will see we're sent over to our main menu screen. So let's fix that real quick. And that is in our game manager where we're loading the scene 1. Let's change, or 0. Let's change that to scene 1. Because scene 1 now is our game scene and scene 0 is our main menu scene. And our restart method so far sent us to scene 0, which now is our main menu scene. So if we change that to scene 1, the game will actually allow us to also restart the game. So let's test it real quick. Let the zombies kill us. So let's press play. There is the zombie. Come on, body, kill me. I always need to go away a little bit because the zombie can only kill us when we're moving. Play again, and you see now we can actually play the game again. All right. So that's it for this video. See you in the next one. Welcome back. In this video, I would like to add another button to our game over end screen here. Because currently, if we look at it, let me activate it. We only have the play again button. I would like to also have a button that sends me back to the main menu scene. So I would like you to try to implement this yourself. So pause the video and go ahead and try that. Okay, so I hope you tried it. I'm just going to duplicate the replay button. I'm going to call this one main menu button. Like so. And now this main menu button should also use the game manager, but it should not use the restart method, but instead it should create, well, it should move over to the main menu. So let's create a new method, public void back to main menu, like so. And what it will do is it will simply use the scene manager to load the scene 0. And also we should make sure that the time scale is being set back to 1 because, well, endgame stops it or sets it to 0 and we need to set it to 1 again. Okay, at this point, let's go ahead and save this script and try it. Okay, therefore we need to make sure that this main menu button here also gets a different position. So let me move it somewhere else. I'm going to move it a little further down here. And let's use -250 in my case, should be fine. Let me change the text of it. So it should say something like back to main or to menu. It should be fine. Or main menu. Not sure if that's good. Back to menu. Should be okay. Then it also fits into the button size. Otherwise, we would have to change the button size and all of that stuff. So now let's just make sure that this button here is not going to use the restart method, but instead is going to call the back to main menu, this one here. Okay, and now let's test it. Well, actually, we need to make sure that first of all the end screen is deactivated by default. All right, now let's test it. Let's get killed by zombies. And this would be a lot easier or faster if we had less health or the enemy would do more damage. So, kill me, there we are. Now let's go back to the main menu. And there we are. Now let's play. And it works. So now we have a working game, even though there are still a bunch of things that we can improve. But overall, the game is working. We have a shooting system. We have running enemies with animations. We have rounds. We have a jumping feature, a little map, and so forth. Thanks a lot for watching this video. I hope you enjoyed it. Now you're one step closer to becoming a Unity game developer. And if you haven't liked the video yet, please do so now, as well as subscribe. And also make sure to follow along in the playlist to become a real Unity developer. And if you want to fast track the whole development process of becoming a developer, then definitely check out our Unity Masterclass, in which you're going to build a bunch of games, and while doing so, learn everything you need to know about game development and, well, have your first couple of projects under your belt. So check it out. The link is in the description below. You will get a huge discount, and I hope to see you in the next video.